Hi, it's Shopi, the host of this program. In the next couple of hours, you're going to hear a conversation with my friend, shall remain nameless for now. Know him for the last couple of years. I had many interesting conversations with him, and since I always wanted to start a podcast where I could share all the stories and interesting people that I meet, and I found their stories fascinating. He is one of the guy I always wanted to pick his brain and record some ideas from him. And in this episode, we're gonna cover science basically. We're gonna talk about science. We're gonna talk about theories of Albert Einstein and Stephen Hawking. We're gonna talk about the universe, its existence, what his knowledge about the universe and physics. We're gonna take gravity apart. He's going to share his own theories on what is gravity exactly, because as he explained to me, we don't even know what causes gravity. There's no answer to it. So he's got a theory on that. He's going to share his thoughts on the latest greatest black hole photo, and he's going to explain why it isn't a real image, which is very interesting. I didn't know, obviously. He's passionate about science since he was a little child. He's a very well-read guy, and since science is his passion, he digs deep into a lot of subjects about science, and that's what I have recorded here. He's sharing his ideas and thoughts with me here on this recording. So I hope you enjoyed it, and just to so you could catch up on where you're going to join into this conversation, because I have just started the recording by testing the sound. So you're going to hear a conversation where he is showing to me that how he fixes a hair clipper machine, one of those electric hair clippers that the hairdressers are using. So just a little background story on this one. He's the kind of guy who hates the amount of waste we produce in our society. He's the kind of guy who fixes everything. His home is full of stuff basically that he fixed. It's amazing. So on this note, where you're going to join into the conversation, we have a hair clipper machine taken apart on the table, and he's showing it to me on the head part of the hair clipper, what he and how he basically fixed it so he can use it again. And this is where you're going to join in. I hope you're going to enjoy this conversation. I found it very fascinating, and enjoy. Thanks for listening.
You see this here?
Uh-huh.
You have two pieces of plastic.
Yeah.
Can you check?
I can.
It's funny. First time I see this appearance. It looked like a lighter. A storm lighter.
It's not.
Yeah, so you see this here, and you see the other one here?
Yes.
It's black on black, so it's hard to see, but there is another plastic here. Of course, it's to keep this one in the good position, or when it moves to my direction, like this, this would go like this.
I see. Yeah, of course.
And when you go like this would go like this. So of course you need two pieces of plastic to keep this. It's clips
in position.
Inside,
yes.
In position.
So what did you do?
And in my other one, with the time of use, these clips here, this plastic broke. So when it was moving in this direction, this was going out. So the result, it was doing this movement.
So
instead of doing this, it was doing this.
It didn't cut.
So it didn't cut. It was moving visually, because it moved very quickly. You don't see anything.
Yeah.
But when you turned it off, when it slowed down during a second, you could see it was like moving like this. So I realized, like I said, I always do this. Like I said, the metaphor of the river.
Yeah.
You see the fact, and after you go back to the origin of what creates this problematic fact.
What I wanted to ask about that is, how do you decide where you starting to find the problems from? For example, in the case of a laptop, you don't know what's wrong inside the laptop. You take it apart, and where do you start to?
Honestly,
I
can give you a reason, but I even don't know. I do this since I'm a child, and I don't realize you understand? For me, it's like, oh, it's this, so it's this. It became like a reflex. So sometimes my girlfriend too, she asked me, oh, how did you know? For the good example is this laptop.
Yes.
When she told me, how do you know is a nut like I said, NAT, I'm not sure it's in English, we say the same.
Yeah.
The connectors. I mean, she told me, how do you know it come from there? And in fact, I had to think to give her an answer because it came naturally. When you have two different components who have the same problem at the same time, you have to look.
So is this
the common point?
It's just the years and the practice.
The nearest common point is this, and if it's not this, then it's a problem of motherboard or a problem of driver. But a problem of driver would occur in a different way, not in that way. So that's why it's by elimination. Like I said, it's like a tree. You go up in the tree, so it's easy because it reduces the possibilities. And sometimes when you have different possibilities, because sometimes a branch can be like this. Yeah. So sometimes even if you go up the tree, you sometimes can have two possibilities of origins of a problem. Sometimes one problem can cause two consequences, but sometimes it's the opposite. The same consequence can be caused by two different problems. So when it happened, then I have to use other way to find the origin of the problem.
What I hear is...
Which is the moment. The moment is very important. Did the problem happen when the computer was running? Did this problem happen when the computer was off? Is it during a transport? During a heat? Yeah. Did you didn't wash it for a long time? Did you use it during 5 years or just 1 year? Because of course computer will receive dust on the ventilation, on the fan, yes. So you have to eliminate many stuff. Yeah.
So what I hear is years and the practice.
Yes. But even when I was a child, I was naturally like this. I built my first shelf when I was less than 6 years old.
Your first what?
Shelf. Poles.
Yeah.
But it was a shitty one. I was
not the IKEA style.
With back of the years, I feel very stupid when I think about my shelf because the back part was more slim than the up part.
Right.
So it was.
It doesn't
not
make
stable.
any sense. Yeah.
No, it was staying, but the problem is I used the iron L. To make it stable. Yeah. But the size of the wood on the top was larger to put bigger stuff. The problem is if I was putting a lot of weight, it was falling down to the front.
Head heavy.
Yeah, exactly. So it's head heavy and larger. And larger on the head. So first it's, we call it the moment cinétique.
I don't understand.
If you have a stick like this and a bar like this.
Yes.
Forget my sunglasses.
Okay, got it. Yeah. And
if you force here, it make a movement like this, because you don't force in the axis of this.
Yes.
You forced at different centimeter.
Okay.
And more you go far, more you have torque.
Yes.
If you go a lot far, just a few grams could be enough to make bolts falling down. You understand? So I had a problem of this. And with the back of the years, when I think about my first shelf, I think I was very stupid to build this. Because it was really simple and like this, except like I said, the back part was not good. Because it was not a shelf who was kept on the side, it was a shelf who was kept by wood on the back. And on the downest part, it was like I said, an iron L to keep it on the ground. And the shelf on the top were really large. In my head it was like to be I don't know, it was my logic when you appear on a shelf, it's useful if something on the top is larger and it's like the movement on your hand, but I don't know why I wanted that. I don't know why I built it like this. I could keep for a few months until it crashed in the middle of the night.
Well, you're 6 years old, so... Anyways.
And my father bought me a child tool because I was stealing his tools and sometimes breaking it and sometimes hurting my fingers. Especially the driller. I was...
You know what? There was a movie, now I just remember from the drill, sorry. Last week, for a few nights, we were watching a movie. So we are sleeping at home, going to bed. And like the whole family is laid down in a bed to watch a movie. And I put on a movie about a guy who lives in Canada in a forest, and out of scratch he builds everything, manual labor. So he's got a manual drill, he's got saws, he's got nails and blah blah blah. And he builds a log house, he do the flooring, he do the insulation, he builds everything from the inside, he builds a kitchen sink.
Toilet as well, I suppose. What called dry toilet? He builds
a toilet as well, he make a hole
in the ground.
He's got a drop toilet outside.
Outside, okay.
Outside, yeah. So he makes the house really nice and cozy. Shelves, kitchen sink, everything. And he's got a big fireplace inside. That's what he used for heating and cooking food. And then he builds outside like the outdoor kitchen with an oven, with a place where he cooks maple syrup in the springtime. Anyway, and for 1.5 hours, all we did is just watching the guy ta 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 whoop 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 ta ta. His dog is coming, bringing something to him. He throws it away.
Because of course he does that without electricity.
Yes.
Yeah, because.
Yeah.
Honestly, it's funny. Maybe it's the same video because a few weeks ago I watched a video on YouTube who was very popular.
It's a this is popular.
I'm not sure it was the same because the video I watched it was just something like 10 minutes.
No.
It was accelerated. All what you saw was accelerated.
This is like a very peaceful. There's no background music, nothing. It's just literally tak 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 zik zik zik. That's it. And the guy doesn't talk.
And how he do the walls? He use
roundish
stuff.
He used the round logs.
We mean the tree itself.
The tree,
without the okay.
He used the trees, and then the gaps in between he used like mud or something with moss.
Yes.
And that's what
inside this he put some pieces of the wood what he cutted. It's very useful.
Maybe
the dust of the wood.
Maybe because all you see that he's just mixing the shit,
Yeah. It's funny because all what you say, it's exactly the same what I saw, except what I saw it was just.
This is a guy with white hair. And,
same.
And he's got a white beard after all.
Yeah, same. But this is not. I mean,
and he's got a sign on his door.
Of course, a guy who does that, he won't be dressed in a North Face.
Yeah, no.
North Face, sorry, maybe you have a North Face jacket
no, like
fucking everybody.
No.
North Face is a symbol of, it's like I am capitalist written off your head.
Yeah, okay.
Everybody have a North Face. You want a funny point?
I don't.
When next time you see a guy with a North Face jacket,
yes,
ask him why you don't feel bad to buy a fucking expensive jacket which is built in China by child, a company which is of course based on Panama or Mon Island or this kind of what you call paradise for money, Money paradise. You don't feel bad and after you go back to your home and you feel happy like you are anti-capitalist, you are a leftish guy for left politic and you have a fucking North Face jacket. When you say that to guys, they always say, oh, but somebody offered to me. Mark, Mark?
Yes.
I think you met him.
Yes.
Mark same, I told to him, you have a North Face jacket, and he told me, it's my girlfriend who offered to me. My father, same. And my father, it was the same. And so, my father...
I never had a single North Face t-shirt in my life.
So anyways, this guy who built a home, of course, he doesn't have a North Face jacket.
No, he's
and of course, he don't have... I have Ray-Ban sunglasses, but of course, he's not in a forest with his Ray-Ban sunglasses.
No.
So when you said he have white hair and a barb, I wanted to say it's obvious he have a barb. When you build a home yourself, that's the minimum.
If this is the same guy, he had like a sign on his door, he made out of steel, and it was a bear on it.
I don't remember.
That was typical.
In the video, I remember, it was like I said, just.
And he has a
minutes.
dog.
Yeah, these two, it have a dog. That's why when you said sending stuff to the dog, these two.
Okay.
And the thing what I remember about the door is he built himself the door too.
Yes, true. Yeah,
the door too.
Same.
And the axiom, the stuff where the door turn around.
Yes, he
these
bought
two
that.
he built. Everything is built himself. But I think it's not the same guy because in the one I see, if I remember well, the toilets, it's a dry toilet system.
When you say dry toilet, what does it mean?
He didn't bring a ceramic stuff, it's a hole in the ground.
Yeah, so drop.
Yeah.
After, that's the same.
I know there is a technique, you make there is a technique but which I don't know.
Yeah, you
what
dig
we
a
call
hole
dry
and you put
toilet. It's not just dig a hole, there is special dimensions and maybe some angle to respect, not to have the smell who come back.
That's like bringing in technology to bringing science to the drop toilet, because back in the days, do you just dig a hole and put a fucking thing on it?
No. I think even in the oldies they have techniques.
Well, the one I use never had
okay.
any technique.
I think especially when you don't have the technology, you have the brain to invent useful stuff.
I was always like in my dream, I have a farm and I have an earth house. I always wanted to have an earth house, and I always wanted to have I learned a lot about it. And so having an earth house meaning usually that you don't have electricity, and you have these kind of toilet. So I saw in one of the documentaries that they made this toilet that was like made with science. So you had like certain ways that the poo goes, and like half a year later, you basically just taking humus out of the bottom of the toilet.
Yeah. This is kind of it can be this kind of dry toilet. It's a hole who go down, then it's something like this. And with the time and the bacteria, etc., it move like this, and after 10 meters later, you get your 10 meters, and 1 year later, you get your compost, or I don't know what to call it here. But it's
compost.
Hummus. Yeah, I don't say that because it is, but the hummus is the same. Is the name of the pea, mashed peas, you know. Hummus.
Hummus. But one is hummus and other one is hummus.
Yeah, but when you are French, the pronunciation is
same.
Yeah. Can you go with me? We make a coffee.
Yeah.
It's not a problem for this?
No, it's not.
Okay.
I'm gonna quickly check the sound. Okay, so in this part, basically, since I was just testing the sound, I stopped the record button, and we went to the kitchen, and he made just a normal Italian style coffee, the one you put on the stove and heat it up. And so this is what you're gonna hear. And I also showed him basically the first 10-15 minutes that you just listened to. Showed him in his ear how his own sounds like after testing the sound. So you're going to join in the conversation while we are in the kitchen now, and we're going to discuss how much he hates basically listening to his own voice. So from here on, we're going to have 2 hours of conversation about science that I mentioned earlier, and thanks again.
We listen ourselves through our body. You understand?
The sound hang on. So start again. So
the sound of my...
We're listening to our voice every day.
But it's not the same tone, because what we listen, it's not. It comes from the inside.
That's why it feels very strange when they record your voice and they play to you. It's like, oh my god, what is this?
So that's why, oh my god. Honestly, I have a fucking nose voice. I hate my voice.
Well, you have to get used to it, because you cannot hate it. It's you. Like, isn't it bad that you hate something about yourself?
Boy, I mean, I don't care. I can hate something about myself.
Yeah, fair enough. But like, I mean, it's like you, for fuck's sake. It's.
I don't hate my dick.
Yeah.
I don't know. When I look my dick, I say, oh, I'm not. I don't know. I'm not a figo. I don't like it. It's not. When I was young, I hate. If you want another example of the sexual one, I can say when I was child, I hated my hair color. But becoming adult, I find it's not so bad, and it can even be a tool. And now I'm proud about my hair color. I'm sad to lose my hair. I want to keep my red hair color now. Yeah, because when you are young, some people laugh about it. But the young stupid boys, they laugh about it.
Yeah.
But when you become adult, you realize it's not an everyday hair color.
It's not a weakness anymore, it's an advantage.
Yeah, exactly, because for girls it can be an advantage. It's
different.
And so that's why with my hair I accept it and I like it. But the voice, I'm never proud about it.
I only want a light coffee, please.
Yeah, but I make the coffee will take less in quantity.
Can I have a glass of water?
Yeah, of course. Big glass or small glass?
Big one.
Very big one.
Thirsty. Thank you.
I have to do quickly before it's warm up.
I can do it.
The coffee. No, it's okay. Just checking. So
Cheers.
yeah, it's a voice. But I think it's everybody hates their voice.
Yeah.
So that's why you say I should get used about it. I think everybody hates their voices. For the reason what you said, we don't hear it the same way.
Yeah, well, why is it that we hate ourselves looking it on the photo? Why is it that we hate ourselves looking at on video and hearing our own voice? Why is that?
In my case, I hate my voice more than my look on a photo. I don't like photos either, but what I hate the most is my voice.
I see.
But it's not disturb me because
you never hear it.
I don't know why. Honestly, it's interesting to think in myself for this. Why in myself I prefer if you do audios than just video. In your position, I prefer you do a video than audio because it learned me to be on the video. So it's good sometimes to do something what you don't want to do. You understand?
I know.
So that's why I wanted to do a video.
Motto of my life.
Yeah. In a way, that's the motto I say why I wanted to do a video. Because it can teach me.
What was in my situation, for example, when I started to put video on my social media about myself, you know, where I just hold the camera and I tell something and I put it outside online. You know, I was so hesitant in the beginning to do that, but now it's like second nature. You get used to it, you know.
And you do it naturally. You do it. Not naturally. So I mean, you do it when you want, or you organize it like every week, every 2 weeks.
Yeah,
every
when I want
weeks.
it. When I want it. When I feel it.
And you have followers?
Yeah, some.
How many?
Well, I'm talking about videos I put out on daily basis, which means it disappears in 24 hours. Usually around 90, 100 people see
And
it.
you are not on a website where you have followers, like on YouTube?
Yeah, I do.
How many you have?
1,000.
Okay, around 1,000. Of course, it's much less than the YouTube channels.
Well, it depends. Some people have 8 followers like me on YouTube. But I don't have anything on it. It's just I put my work online and that's it. But if I would have I don't know. That's why I want to have interviews, because I you know, like we had so many conversations that you're like an interesting cat, and I just wanted to put some thoughts online because I think there's a lot to learn from you. Like,
but it's a bit a paradox, because if you do it for the others to be viewed, why you don't do on YouTube more?
Yeah, well, I need to start.
I don't say it's a good stuff, the YouTube game, but the fact it exists, the YouTube game, and
yeah.
I know it's a guy who just do little videos will have a little amount, but if you just at the end of every video said subscribe to my channel, it's amazing how it works on YouTube.
Mm-hmm.
It's not amazing, it's pure logic, because you target a lot of people. So even if there is just 1% of person who subscribe when they listen, please subscribe. This 1% will subscribe, so you will have more subscribers, so more people who listen, etc., etc.
Mm-hmm.
And the people go where people go. That's the problem of restaurant. When they open, many times they pay fake customers to look like full at the opening. Because if it's empty,
nobody's
people
going
walk
to
in front and nobody will enter.
Yeah.
And this in Japan, it's 10 times more. In Japan, it's amazing.
What do you mean?
In Japan, when you do open a new restaurant, and I was working for the opening of a new restaurant, and it was amazing because they paid enough customers. I mean, they paid fake customers, but to be totally full. Not to look like a little bit full.
Right, so people can't get in.
Exactly. They faked the fact it was totally full. And Japanese people started to make a queue outside. And this is amazing in Japan. People can make the queue to enter in a restaurant.
But what I don't understand...
Yeah, I never make the queue.
And me neither. But like, what about so what are the fake people eating? Like, you know...
Oh, they eat really?
Pardon?
They eat really. It's like a job in Japan. You have some, you make some...
okay, so maybe that's your pay that you can have free dinner, right?
Yeah, exactly. And you receive a bit of money. But it's legal, and it's not an illegal stuff. Huh? I remember my boss, when I was doing the job, he was putting some stuff in newspaper. We look for people who want a free dinner plus €100 extra. I mean, not €100
to make an advertisement.
It's like 10,000. It's funny. In Japanese, 10,000 is a unit. These two, even Japanese people, because it's their own logic, they don't realize it's unique, this logic. In French, or in English as well, 10,000, it's 10 times the unity, which is 1,000. I mean, the unity, one of the unity, The unity can be 1, 10, 100, 1,000, million, billion for the English, or milliard for the French. English, they have another stuff, they have trillion, as well.
Yeah.
Trillion, we don't have it in French, we don't have the name for this. But after we have the mathematic numbers, like the Google, where come from the name.
Yes.
But it's something else. But technically, this is like a name, a unity of something. But Japanese, they have a name to say 10,000. They don't say 10 times something, they say one name for 10,000. It's man, ichiman, M-A-N, man, ichiman. It's 10,000. So it's strange, no? Sorry, I changed subject, but because
in English, in English they say 10K.
Yeah, K like kilo.
Yeah.
Yeah, but in that case.
So 1,000 is 1K, and
but
10,000 is 10K.
Yeah, in that case the unity is same. It's 1,000.
Yeah.
K just means 1,000.
Yes.
And K is just a slang language.
Yes.
It's
that's why I was asking.
It's kilo, like kilo, mega, giga.
Yeah.
Hepta, penta, when the one we never use. Tera, of course. No, I forget. After giga is tera. Yeah, we know it thanks to the hard disk. Tera, penta, hepta.
No
I think I never. I mean, we always learn the others, but I never remember.
Cool.
And you said you wanted to discuss about something more science, etc. But for me, science.
I discuss anything.
Yeah, and in fact, Lutza, she started to really, Lutza, my girlfriend, she started to really know it. Then why I like science and politics. For some people, it can be totally not connected. And why, in the same time, I will discuss about physics théorique, about high-level physics. I will repair a fucking battery. For me, all of this is the same, in fact.
How?
It's because, like I said, I have a trick to do all of this. I imagine in my head, I recreate in my head what I see and what I feel. For example, something was very bad to me. It's when I was at school, I learned the atom is like a ball with something with the center and some little balls turning inside. Electron. And the center and the neutrons. But it was bad in my case to learn that way. Because for many years I was focusing on the imagination, it's a ball, and one day I was thinking, okay, but if it's like an egg, then how is made the shell of the egg? You understand? If it's a ball, which is the material of the cover of the ball? It cannot be material because we are under the matter. We speak about something
smaller than matter.
Than atom, because the atom we call it the elemental brick. I mean now, no, because we know there is a
smaller particles.
Yeah, of course. Now we consider the elemental bricks like the electron, bosons, etc. But the microparticles. The microparticles are not matter. M-A-T-T-E-R.
Yeah, matter.
Yeah. They are not yet. They are too small to be. And it's not even too small to be visible. They are even not. They are invisible. They have no. Even if you, I don't know. In theory, it's impossible. But imagine I make your glass here. I make the sound for this. You make the glass full of X bosons. It will still empty.
Yeah.
You understand?
Yeah,
of course, you cannot.
I understand.
It's not a stable stuff who can stand alone. But imagine you create a machine, a special glass who can hold just the boson and nothing else. It would be empty because the boson is not yet. It is very small bosons.
Okay, so going back to the atom, they confuse you when they told you atom is like something material.
Yeah, because I started in my head to imagine it like in 3 dimensions.
Yeah.
You understand? And same for the timeline. I was imagining, like many people, the time as a line.
Mm-hmm.
And these two I stopped. And in fact, I always make... Technically, it's a brain problem what I have since I'm a child. I don't speak every day about it, but there is a name. Some psychologist told me, even in English, so I know the name. It's low latent inhibition.
What does it mean?
Déficit d'inhibition latente in French. It means your brain naturally, I don't change subject, it's totally connected.
Okay.
If I'm speaking with you and if I do this, naturally your eyes will look, you see, and if you sleep, your brain will hear sound, but you won't wake up always. If you are sleeping and if I do this, you won't wake up. But if you are sleeping and if I heard on your door, then you will wake up, because your brain will make the difference between what is important for him, for your consciousness, and not important for him or not important for your consciousness, which is not the same. Him in the way your brain and your consciousness is not the same. The needs are not the same. Everybody have what we call a latent inhibition. What your brain selects
I understand.
to think about and what it don't select.
Yeah.
The low latent inhibition, in a way, it's a weakness, because it's a job what your brain don't do well. It's not your brain works more. He doesn't do this inhibition.
Meaning
enough.
he doesn't select. Your brain doesn't select as much sound as supposed to.
It's just an example.
Yeah, I understand, but like.
No, he doesn't make a selection. He selects in a way, he grabs them, but he doesn't choose.
Okay.
He doesn't choose any stuff because everything arrives.
Yeah.
If I can give you a stupid and simple and true fact, I sleep very wrong. I never sleep well.
Yeah, because you have all the sounds are
any sound
disturbing
wake me up. If you want to tell a secret, actually it's a problem with my girlfriend.
I understand.
She just breathes too strongly. She's not like this, just she breathes like this, and I hear every of her breath, and it's a bit problematic for me actually. Because I cannot ask her to stop breathing.
But it would be very difficult for you to sleep in, for example, if you would live, in downtown where there's traffic all the time at night.
That's why I have a flat in a Udvar.
Yeah.
But it's not a problem. I wake up and I fall asleep 1 second later. I'm used about it. Do you want a big cup like this?
Any cup. Like
no,
small is fine.
Depends if you put milk or not. If you don't
I'll
put
put
milk.
a little milk, yeah.
Okay.
So how does this brain selection connect
so we are between boys. A girl I would serve yourself like this. You have the quantity of coffee you want.
Thanks.
Yep. So what was your question, sorry?
So how the brain selection is connected to the subject about the atom that we were discussing? I understand, sorry.
The connection is the fact, naturally, I create, how can I say, a 3D model in my head.
I understand. Right, okay.
That's why, for example, the first time I learned, it's something that we know since a long time, but I learned it maybe 5 or 10 years ago, not when I was a child. The fact a very massive object in the universe will create a deviation of the light. This, when I learned it, it was very logic for me to learn it. It was, of course, of course. Of course, because even if the photon it's what we call dualité onde-corpuscule. The light is calculated like a wave, but technically it's a corpuscule, it's a material. It's not material, but it's microparticle, the photon. You understand? And it's a bit special, the light.
Okay. Because
the calculation you do is like one of the, there is a 4 big energy, the nucléaire fort, nucléaire faible, électromagnétique, et gravité, and gravity. And the electricity, the light is like a wave, like electromagnetism, but it's not a wave it's not like a radio wave, it's a photon, it's a movement of microparticle. And it's It's interesting. Anyways, like I said, duality on corpuscule. The light is a bit special because, like I said, it's microparticle who what we calculate, and the calculations are good when we do like this. So it works. Technically, in physics, it works. But we calculate like if it was a wave, even if we know it's not a wave. And for me, it was obvious because even if we calculate it's a wave, it's not a wave, it's photons. Like every stuff who exists in our dimensions, they are subject to the gravity. Everything is subject to gravity. So for me, when I learned it, it was very logic because I imagine in my head, and yeah, it's obvious. You have something massive. It creates like a shape in the form of the universe, and you know that's the Einstein theory that the gravity is not. The gravity is like a second effect of the modification of the shape of the universe. Have you never seen these videos when you take a tissue and when you put weight on it, it's make like a cone around the massive object?
Yeah, I've seen it.
And something turn inside the cone.
I saw the drawings in my head now. Yeah, so I saw it.
Technically, for example, these two, if you really imagine well, you can directly think an orbit. You don't turn when you're in orbit. When you turn around the Earth, you are floating. You understand what I mean?
Yeah.
You are not going up or down your spaceship. You are in the middle of your spaceship like this. But you are turning. So you are locked between the gravitation of the stuff you are turning around, and you have the centrifuge effect, who should put you to the outside.
Centrifuge.
And you are locked between, but it's not because of this you are floating. If you float, it's because, like I say to my girlfriend, there is no difference between a movement and no movement. In universe, there is not a question of moving or not moving, because we even don't know the form of the universe, and if the universe is infinite or if it have a end. If it have an end, maybe it turns the universe in something else. It's a semantic problem. But if the universe have an end, what is after would be called the universe as well, because universe means all what exists. Anyway, all of this is naturally in my head because I built like a maquette, a model in my head. But I take really care not to make a model using the 3 dimension, and this is a bit technical. I don't use the 3 dimension because using the 3 dimension it fake you. You will have, that's what I always teach to my girlfriend, that if you imagine the universe in 3 dimension, then it will be hard for you to understand some stuff who can be very easy to understand. Even very high level science can be very logic if you stop to imagine how they teach you with a 3 dimension. And it's normal they teach you like this. The teachers and school is normal because they have to teach you how look like an atom, so a ball. But the problem is, even if in your deep inside you know it's not a ball, you continue to imagine it like a ball, and this is very dangerous, because if you remove your imagination like this, it helps you. You can imagine it just as a cloud, for example. That's how I imagine an atom. But this too is an imagination, of course. But at least a cloud have an idea about something invisible. You know, a cloud from far you see it well, but when you go closer, it's not, the cloud is at 1 meter from me. You know, when you go closer to a cloud, the cloud disappears. Because what you see is a condensation of the H2O molecules from far. When you go closer, they are not so close to each other. Like the rings of Saturn, for example. From far we see rings, but when you go close, there is kilometers between each asteroid who turn around. Really, kilometers. You could cross them with closing your eyes with your spaceship without being afraid. You have the same chance to receive an asteroid crossing these rings than, I don't know, receiving an asteroid on your head when you are driving on a car on a speedway.
Oh, wow.
This one is yours, so
yes,
you sure you don't want more coffee?
No, that's fine, thank you.
Tell me stop, because it's really not a lot.
Thank you.
Really?
Yeah.
Okay. Me it will do bit
double than yours. Is that a self-closing milk bag?
No, but it's like this.
It looks like it's self-closing.
Yeah, it's not self-closing. It's very useful because look, it's it stay closed.
That's what I'm saying.
Yeah, but it's because of the capillarity. Vacuum. No, it's not a question of vacuum. It's because there is a liquid on the side, a liquid on one side.
Ah,
so
gotcha.
why air would go inside?
Yes.
Like
talking about spaceships.
There is a name for this. Yeah, but this is tension surface. Why the water doesn't fall down? Because the gravity effect of this drop is too light to be attracted by the ground. If I do this, it will be attracted by the ground. Of course, emptiness, it won't float, it will be attracted by the ground. But the force of attraction and the force of friction of my skin is not comparable. I mean, it's comparable. The force of my skin is stronger. On this surface, my skin is stronger than the gravity, so the drop prefers staying there. Yeah. And that's the same reason when you put a drop on a flat stuff, the drop stay as a drop and not stuff. It's related a bit to the
surface tension of the water.
Yeah, and the always I mix Coriolis or Archimede. Always I mix.
Je ne sais pas.
Always I mix. You know when you make this full, the water will be a bit like a ball on the surface.
That's the surface.
Yeah, the surface tension, like you said earlier, is connected with this. Yeah.
Merci. Sugar? No?
I need my coffee, yes. Just I check what is remaining. Sure you don't want more?
What's it called? No, I'm fine, thank you.
So yeah, to my girlfriend, I always teach her to... because for example, just a few days ago... Okay, I hope she won't listen to this audio one day because she will be disappointed if I reveal something. Just 2 days ago. Wait, we are Friday? Thursday, Wednesday? Yeah, 2 days ago. 2 days ago, she told me, because I told her we discovered a planet who turns so quickly that she's almost flat. I mean, almost. Just a third.
Okay, slow down. Where was it?
A planet who turned very quickly. We saw it. I mean, we didn't see it because we cannot see a planet out.
Us, Earth?
No, scientists.
Okay.
Some scientists, they, I say some because now we discover hundreds of exoplanets every day, literally. It's very easy now because there is billions of stars that we see, and we study. There is many ways to study. You can study the micro movement of this light. It means, the sun have an effect on the Earth, but the Earth have an effect on the sun. Not only the Earth, of course.
All the planets.
But all of the planets. Jupiter, far but very big, have some effect as well. The Earth will have some micro movement.
Wobble.
Due to the... Of course, if the sun attracts us, we attract the sun as well. Less, of course. But there is an effect. Like the moon have an effect on the Earth. Because of the Earth, the moon turns around. But because of the moon, the Earth have these big waves. Depending on the moon, when the
ocean level rises.
Yeah, exactly. Because of the gravity of the moon around. You understand? So the Earth too, same. So studying this micro movement of light in the stars, you can check if there is planets who turn around. So there is a planet, but you never saw this planet because these planets, they don't send light, and they are out of our solar system. So that's why we are very far from seeing with normal spectrum, our vision, even through satellite, through satellite as a telescope, we are very far to see planets. The James Webb Space Telescope will be maybe able to see some planets like in Proxima du Centaur, like some big planets, some rock planets turning around. But even this, it won't see it in proper light. He will see it in frequencies, and he can receive frequencies who are out of our. It's not like Hubble. Hubble, it's a very classic telescope who receives light. But now we built telescopes who receive the infrared, who receive the magnetic wave.
Ultraviolet.
Yeah, exactly. They receive many stuff. That's how.
Yeah, that's how they make all these amazing galaxy photos of other Milky Ways and galaxies.
Yeah, except sometimes they try to make it look how you will see it. Sometimes they don't. Sometimes they add. Sometimes they don't. That's why I don't like the fact actually, but it's my problem, I have to accept it, that actually we are... I left the remaining coffee for you if you want more later. Okay?
Okay.
Because you didn't take more. Yeah. Sure you don't want more? I can make more.
No, super. Hang on. Can I put it?
Yeah, of course. So yes, it's the distance between what is a real picture and what is made by computer have to be changed actually. Because we have to admit all what we see. Of course we consider, yeah, this wall is yellow, but no, we see it yellow.
Yeah.
Why it should be yellow, you understand? And it's a bit the same. For example, there is a beautiful picture called the pylons of the universe, or the finger of God, or there is many beautiful astrologic picture.
Yeah. The horse head.
Astronomic picture, but
I saw one that I want to show you.
You can never know what is true and what is not true, what we would see and what we would not see.
I saw a documentary. I saw a documentary movie about Hubble, and like, you know, I remember that they said that you take a telescope, you shoot it towards the sky, they take a photo and all you see is blackness and some dots on the sky. And as soon as you start to put the infrared filter, the UV filter, the magnetic filter, the blah 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 on it, and you have all these different, you know, spectrums and colors and everything popping up.
Yeah, but which is not, it's really in a way or not really not, depends on what we call being real.
Yeah, because like, if like, now you talked about the spectrum of light, right?
Yeah.
And if the spectrum is, I'm not sure if it's 100, but if it's goes from 0 to 100, people or humans or our eyes can see 10% of that 100% spectrum.
Yes.
So the light spectrum is like, we like half, not even half, we like almost blind to what.
Yes.
You know what I mean?
It's, you can think like this about all of the existence.
Okay, this was just only visibility, yeah, or the visible spectrum.
All what we see, it's the interactions, in fact.
Yeah,
when you see a light, it's because you see the photon. If you receive a radio, it's because some radio arrived to you. If you receive electricity, it's electrons who are arriving through you. I mean, it's all what we see and feel is fundamental interactions. If there is no interaction between elements, there is no sensations and experiences. Yes. And it's always I like to think some alien forms who could
be amongst us and we can see them.
No. Why amongst us? Why they should be like we consider to be? Why they like I said, for example, we always say
again thinking in 3D.
Yeah, exactly. Mm-hmm. I try to be out of the vision of the 3D and this, because all of this, it's us.
Mm-hmm.
We are. I really don't like Stephen Hawking. Mm-hmm. So I won't speak a lot about his theory because I consider it shit. I really don't like. Always I say sorry for what I say to the microphone, but if Stephen Hawking was not in a fucking chair, in a wheelchair, if he was not in a big situation of handicap, we wouldn't scream that, oh, he's so genius, he's so genius. He's a good scientist, but for me, Stephen Hawking do something very wrong, what everybody would say if he was not in a situation of handicap. Mm. When you do science, you try to check what is wrong, not to prove that you're right. You understand how important is it? Mm-hmm. You must have a theory and then try to make it wrong, to break it. And if you cannot, then your theory may be right.
Yeah.
And the relativity theory, and both of them, the general and restreint, I don't know in English.
Okay.
Both of them works well from Einstein, but we still call it a theory, even if we know it works. Because it works, but we cannot still, how can I say, in a way, prove it. For one of the main reasons why we cannot prove it is because we still don't know the cause of the gravitation. We can calculate the effect of gravitation. We can even calculate the effect of gravitation I have on you or you have on me, which wouldn't be the same. But we still don't know what, technically, in a way of the fundamental, the basic physics, how it works. So Einstein supposes it's like a movement and torsion of the shape of the universe. Maybe my word shape is not the best, but I think you understand using the word shape. But it's again, it's a way to see the stuff. So if you build a model in your head, that's what I explained earlier, you can build a model, but you must separate in your model what is visually acceptable and visually useful to think, but not acceptable. After you know the atom is not a ball, you can put back a ball in your model. But if on the side of the ball it's written, this is not a ball, in your head, you understand this metaphor, what I do now?
Mm-hmm.
And it's very important. And since months, I have these discussions with Lutza, because she tried to be better in science, to understand what I speak about most of the time. we go back to sit down?
Yeah, let's go.
And
did you put sugar?
It's here. But to follow me, she really have to do this job. And so now comes the mistake what she did 2 days ago. she was looking at me, and we were discussing about the like I said, I will restart what I said earlier. We discovered a planet.
Okay,
that's why I say we, because it's a team. First, it's a team job, and then it's not human who discover it; it's machine who checks the sky. Now, so that's why we discover hundreds of exoplanets every day. But this too, it's another subject we can speak about. But I hate this. We say we look for life, and we look for life at something which is similar to us.
Yeah.
And we say, yeah, but we only have one example, it's us.
Yeah.
It's not because the fact we say we have one example of life, it's an excuse, it's not a fact. It's true, but not everything is true can be a good excuse, you understand? It's a fucking fact, yes, we know just ourselves. But this is an excuse. It's not because we are based on carbon that we will discover other form. Mm-hmm. It's not because we need water. Then everybody say, oh, a planet who have water, it could be life.
Mm-hmm. You know what's my view on that?
I have to say something. If somebody listens to this, what I'm saying now, it's my opinion. Sometimes, this is very important. I want, maybe you can even add it at the beginning of the audio. I refuse to see the universe and the laws of the universe always has somebody discover it, so it's right. You understand? Of course, I trust it's right. But I'm a bit flexible with it. For example, I don't agree with some theories. For example, in my opinion, the graviton doesn't exist. While it's the main theory, actually. But I don't say the Earth is flat. You understand what I mean? But for me, the graviton doesn't exist. We still didn't discover it, so maybe I'm right, but maybe I'm wrong.
When you say graviton, meaning gravity, or what is graviton?
Yeah. We suppose the existence of a microparticle who have effect from the gravity. Yeah, because like I said, we know it exists, the gravity, but we still didn't do physics quantique. Mm-hmm. Like I told you, there is 4 fundamental forces. Nuclear fort, nuclear faible. Fort means strong and faible means weak. Mm-hmm. So I will try to translate in English, but these two, the people who listen, they have to take care about this.
Your translation.
My translations. But people who know the basics, they will understand, of course. And when you say 4 forces, they know which one I speak about. So the weak nuclear forces, the strong nuclear forces, force, not plural, singular, the electromagnetism and the gravity. 3 of them, we can do physics quantique about it, which means we know how it works inside the atom about it. Mm-hmm. We know exactly why the electricity works. It's because of a movement of electron, which is a microparticle, what you can calculate. We know about the spin of the particles. We know many stuff about it. But the gravity, we can calculate the effect in the universe, thanks to Einstein, and not only Einstein. Before it was Poincaré, or there is even a different way to see the gravity who can be right. There is first the gravité aristotélicienne, like Aristotle, which is in my case, in my opinion, a shit, but at least, like everybody say, Aristotle was always wrong, but at least he had idea about everything. So Aristotle had idea about the gravity. So there is a first way to see the gravity. After it was, of course, gravité newtonienne, how Newton saw it. Between that, it was Galilée, relativity, and gravité selon Galilée. But this, same. It's not so true. But at least Galileo was much smarter, I think, than Aristotle. Not smarter, more scientific way. Aristotle was more a thinker. He could think about every stuff, but he was always wrong. But it was thousands of years ago, so we can forgive him. So anyway, the gravity, we still didn't do the physics quantique of the gravity.
Mm-hmm.
So this fundamental force doesn't have the full knowledge for now. And that's why we suppose, but we just suppose it exists a particle who interact with this shape of the universe, if it's a shape of the universe, but same, this is a vision. You understand? It's a way to make like a metaphor in your head, not to be lost, because we are in something which is way much bigger than us. Mm-hmm. This is a semantic and philosophic question. Are we supposed to understand the world in which we live? But to continue what I say, it's sometimes I have opinions who are out of the main opinion, like this graviton. Most of the people would say
like
it exists.
Mainstream.
Yeah, and and in my case it doesn't exist. I have many reasons why I think it doesn't exist. Many experience what you could do who could be funny. Like for example, if you make a big hole in the ground to go deep, imagine you go at a 3,000 kilometer deep. Of course, imagine, because you will be totally crushed by the pressure, etc., and it will be too hot to survive. But imagine you could. Imagine you send a very strong ship, so very strong to hold the heat, the radiations, and the because I suppose at 3,000 kilometer closer from the center of the Earth, maybe you could receive some radiation. Yeah, because it's like a nuclear core, the mm-hmm. center of the Earth. So, mm-hmm. so you will die quickly. But imagine you are in a ship which is made to resist. If you are half of the way to the center of the Earth, you receive more or less gravity in your body. How you will feel in your body? More heavy or more light when you go closer to the center? Because we know the gravity attracts us to the center of the Earth. Yeah. The axiom of my body is the direction
straight up.
Exactly. It's of course orientated to the center of the Earth.
Yeah.
So if I go closer to the center, should I receive more or less gravity? And this type of questions, they are very interesting. Unfortunately, we cannot do it by an experience because the deepest hole we could do is 12 kilometers. Yeah. It's called Forage de Kola in a northern country. I don't remember which one.
The deepest hole we can go? Isn't that Mariana Trench?
No, this is a natural place.
Aha.
And it's same, it's 11 kilometers deep.
Really?
At the deepest, it's 11 kilometers. Mm-hmm. But the deepest hole the human did, it's a hole big like this. Huh?
Ah, okay.
It's a tube very long and it's 12 kilometers long.
True.
Yeah.
So what I wanted to say, going back to the aliens that...
Yeah. If I spoke about this, it was because really I wanted to explain that sometimes my opinions can be different than the main one. Uh-huh. But of course, about what is proved, of course I agree with it.
Yeah.
But we say in science many stuff. Sorry to cut you for this, but I really wanted to finish for this gravity stuff.
Tell me.
Many times you have people who say, yes, the graviton exists. Look, it exists because many years ago we supposed the existence of a particle called boson. A guy called Higgs, of course, supposed it. We supposed, and the guy, Higgs himself, died. He died, but I think he died a long time before. And in the modern days, just a few years ago, we did some experience thanks to the collisionnaire de Hadron. This big, this big stuff, I don't know how to call it.
Collision, whatever.
Yes. So thanks to this, we could for the first time discover and prove the existence of this, mm-hmm. because we could make it exist, mm-hmm. of course, for few microseconds. You know, it's not a stable stuff. Like I said, the boson cannot survive in a glass of water like this. You understand? It doesn't exist as a standalone, but you can prove the existence through the interaction with other stuff.
I understand.
Because every particle interacts.
Mm-hmm.
And we could prove it exists. So, look, we suppose the existence of something, and years later we prove it exists. And before that was the story of the black holes. Black holes were supposed in the history. Just supposed. It could exist. What's happened? Okay, the Earth is big. Jupiter bigger again. The Sun bigger again. Supernova bigger. Bigger. But there is a moment when it's so big, then it's so heavy, that the speed to go away from this stuff is higher than 300,000 km per hour. We call it the liberation speed.
Okay.
The liberation is the speed you need to go to be stronger than the gravity. Mm-hmm. The gravity depends on how heavy is it. Mm-hmm. You agree? Mm-hmm. The Earth, for example, we need to go at something like 10 or 11,000 km per hour to extract. It's a freedom, vitesse de libération, we say in French, mm-hmm. of our planet. But of course, if you take something which is big, maybe this speed, which is necessary to go out, will be 310,000 km per second. And in that case, this speed is higher than the speed of light. So it means it's impossible to go out, mm-hmm. because the speed of light is not is the speed of light. It's not the speed of the material. It's not the speed of all the atoms or something. It's the speed of the light. It's a limit, and it's a limit for the light. So for the other stuff in the existence, it's smaller again, lower again.
Yeah.
It's so that's why it's because we suppose many times stuff who exist. Many people will tell you, oh, the boson exists. We supposed it and we discover it later. The black hole, we suppose it and we discover it later. So of course, the gravity, we suppose is due to a graviton. Soon we will discover a graviton. But for this, I don't agree. It's not because 2 times before you have example about something what we discovered, what we thought before discovering.
And
yeah, exactly.
You're lucky enough to discover it.
Exactly. Thanks for your English, which is better than mine. But you understand now? Mm-hmm. And that's why I wanted to finish this, because sometimes I have opinions who are a bit different, but it's always when it's not proved and when it's not yet admitted. Mm. So yeah, you're thinking about alien forms, and for this
because
too, I have
what I wanted to just quickly reply half an hour ago was that you said that we think in terms of like 3D, and when you say alien form, you're always thinking of a big-eyed guys walking amongst us, and just think of the universe, and if you look at the age of the universe, you think about a few 100,000 years, maybe 100,000 years. 100,000 years ago, there was no human fucking beings on the earth. Maybe, and just look at the grand scale of the universe. All you need to do, if there's a planet, and that planet is just a few 100,000 years behind us, you could be talking about only bacteria as living life forms. And this is what I'm trying to say, like, what are the chances that the life form that, if there exists in the universe, is going to be walking on 2 feet like us, and
I agree
and not going to be a bacteria, for example.
I agree with you. I totally agree with you, but not in the way you said. But I agree.
Yeah,
I agree, but not in the way you said, because what you said is true. When you said if you go far, of course, if a guy is far, they will see, of course, the planet without the humans, because if the planet is 200,000 light years away from here, and if they have a very strong telescope, they will see a planet without humans.
Not away, behind, in the age of the Earth.
Yeah, of course. No, we say the same.
Yeah, okay.
Yeah. If you have a planet which is the light years is the unity of distance.
I'm talking about age.
Yeah, me too.
Okay.
I understand, but is the age is different than the time?
Yes, that's why I'm confused now.
No. Okay, I will say, but tell me if I'm wrong, because I thought that what you said, I really thought that you said that. If you go 200,000 light years away from here, and if you have a telescope and if you look the Earth,
okay, I got you.
Then you see a Earth without human, because the human doesn't exist yet. Mm-hmm. I suppose that's what you said.
You could translate it this way, because all I'm saying... Yeah, you're right. Yeah.
Okay.
Yeah.
But the point is, you just speak about the photon. Mm-hmm. You speak about what you see.
Yeah.
You are saying what you see is the past.
Yes.
But it's not because what you see is the past. this past is past. You understand? If we see a planet, of course it's famous. Not a planet, let's say stars. The stars, what you see, some of them are either dead.
Yeah. What you see is the light still coming.
Exactly. But it's not because we see it, then it's not dead. You understand what I mean? And it works in the opposite way as well.
No, I wasn't...
We cannot base our knowledge on what we receive, of course.
I understand. I wasn't talking from this angle. I wasn't saying that what we observe. I'm talking about, in general, the age of the universe.
Yes.
You know, if there's other planets, and that planet is 200, 300, a million years behind Earth age. I'm not talking about we looking at that. I'm just saying it exists.
Yeah.
You know, 1 million years, there's nothing. It's just volcanoes and fucking fire and ice, and that's it. On that if there's water.
Yes, but in fact, there is something, we are not so ignorant for this. In fact, there is many statistics we can do without using the human in it. Because the problem is, if we use the only example what we know, us as a evolved human species, you know, we are the only one who wear dress, for example. And this would be another question as what we call evolution. Why an alien form intelligent would need to take dress? Are we more evolved than some other species on our planet? Are we more evolved than the ants, for example? The ants have a very complex life form, very complex. They live in society, they communicate, they have a role in a sociology in there. They have a architecture of their society. So they are very, very evolved, the ants, very. And they exist for more than the human. So if an alien comes here, why he would think we are the most interesting? Why would we wouldn't be just a parasite? Because we are weak and we compensate our weakness with technologies.
Yeah.
And but we have something what nobody else have. Is what we could call the conscience. No one, even
conscience.
It's not exactly conscious. Even the ants, they don't wake up saying, "Oh, how look like the universe." Only the human is able to think like this.
The simple way to say it, we are the only ones asking why.
Exactly. Yeah. It's a beautiful way how you say now. I like how you say that now. I will maybe steal this sentence one day. Yes. Why? Why with the point after? I mean, not why this, why that, why everything. Why? Yeah. We ask question pointless about existential stuff. Yes. And really thinking about the alien forms far from us, we have some, like I said, some tips to help us, because we can extract for the humanity. We can forget the humanity. We can just think about the statistics about time, because we know how long the universe, how old is the universe, and we know the end of the universe as well. Of course. We just don't know about how it will end. It depends on the dark matter, you know.
That's above my pay grade.
It's what we don't know yet. Do the empty part have an energy or not, and which kind of energy it have? Because normally the extension of the universe should be faster. Again, something is like keeping a little bit the stuff together, which is not the gravity. Of course, the gravity does, but we speak about something at a higher level than not higher, more extended level than the gravity. But so that way, because of this miss of knowledge, lack of knowledge, we still don't know if the end, if the universe will finish at what we call a big crunch or a big freeze. In one case, everything goes so far from each other, it becomes cold. There is not enough energy to keep the stuff, and it becomes cold in the way cold. The energy is not strong enough to go from a place to another. There is no more nuclear reaction, no more. Little by little, all of the four energies, fundamental energy, will freeze. And we imagine an end like this. On the other end, we imagine it's a big crunch. It's due to this weakness of the interactions. If there is a dark matter who keeps the stuff together, who won't be compensated by the expansion of the universe, because this will be down, because it will be no more force to keep it, it will crash back. And like the Stephen Hawking theory, it will crash back, make a new singularity, a new Big Bang, and a new universe. It joined a bit that one of the Stephen Hawking's theory. Earlier, if I said about I don't like Stephen Hawking, it's Stephen Hawking's theory. Of course, I say in one sentence several books. So of course it's more technical than this. But in a part of the stuff which I don't like from Stephen Hawking, he say, my theory is valid, but only if there is more than 3 dimensions, and these other dimensions, we cannot see them because they are folded on themselves. Fuck my ass. When I listen, sorry, I know it's bad what I say, but when I listen to this, I say, you are lucky to be in a position of handicap. Because if you wouldn't be in a position of handicap, some scientists would tell you, it's not this way we work on a theory. We don't say my theory is true only if. No. This is a sign your theory is not so true and you have to correct. There is many interesting stuff in the theory of whole. Because that's the point. Stephen Hawking, like many people, try to make a theory who put the gravity as well inside. Like I said, we have a big problem with the gravity. We cannot put with the others. We don't have we miss what we call a physique quantique, gravité quantique. The physique quantique applied to gravity. Which physique quantique sounds very technical, but it just means the physics about what is smaller than the atom. So yeah, and so that's why I didn't change subject. Your question is about other life form in the universe, but we know how old is the universe, and we know when it will end. It's like a human. If I know you are 40 years old, I know you are the half of your lifetime, more or less. You understand? It's the same with the universe. We know how old is he. How old it is. We know how old it is. So of course, and we know how old the humanity is, and we know how old the Earth is. You understand? So of course, by statistics, we can say, okay, our planet is more than 4 billion years. There is many planets around us who are more than 4 billion years. We needed all of this time to go from a simple bacteria to us. So, and the universe exists since 3.6 billion years. So we can imagine, if we consider it's a problem of time, there is other life form. You understand?
There is other life form.
Yeah.
Yeah.
No, I don't trust in it. I say if you want to base your calculation about, like I said, the fact of the time, we exist just from 100,000 of years, and there is planets who are 10 or 20 billions of years.
Yeah.
You understand?
That's what I'm saying, yeah.
I mean 20 no, because we cannot see a planet 20 billion years. You know why? Because, yes, you understand.
Tell me.
The universe, like I said, it's a bit more than 13 billion years. Yeah. So it means if an object is at 20 billion years away, we cannot see it because it's not born yet in our eyes. That's why when you see very far, you see the birthday of the universe. That's what we call the fond diffus cosmologique. You know what is it? Fond diffus
this
cosmologique?
is again above my pay grade.
If you look very far, you can see the origin of the universe because, of course.
Can they see that far?
Yes. Even with Hubble, Hubble Deep Field. Hubble made. It's not a video. It's we should do a video for this. Now you let me speak like this, how I like. But if you need, I focus on one question after the other. I'm able to do it as well.
It doesn't matter.
But in that case, you should stop and restart. If you don't want to do a cutting and choosing, or
no, I'm gonna just carry on going.
Okay. But if you want, we can say you ask me a simple question or technical, asking me to focus on it, and I'm able to do it. I insist, I'm able. Hubble Deep Field. It's like if you do more or less, it's more or less, of course, and it's more a way to see it than exactly it did. Hubble took a picture like this. He was focusing, Hubble, it's a satellite, which is a telescope, outer space, and during weeks, of course, it's in orbit, so he couldn't stay in the same point, but every tour what he was doing, he was taking picture during several seconds, and he accumulated weeks of focus opening. Yeah, of course, because to receive the light of something which is very, very far,
You need a lot of the
yeah, exactly.
The lens to be open for a long time, so it receives all the light.
It's funny because some photo cameras, they are open for microsecond, and now we speak about weeks of opening.
Fuck, the Hubble, which is like a meter diameter.
And it was focusing on a point which is 0.2% of second dark or something like this.
What does that mean?
You know, in cosmology, you always calculate in the angles in a second dark.
No, I don't know.
360 degrees, you divide it.
Yes.
So you don't calculate in degrees, but in second dark.
Okay.
Anyway, this angle of vision is so small that the degree wouldn't be so exact.
Wow.
So we use something much smaller and much more precise than the degrees for the 360.
Yeah, because it's so far, so it's so fine.
Exactly. So the degree wouldn't be good because you would say, okay, you have to turn from 0.0000006 degree. So that's why we use what we call second dark and even microsecond dark.
Jesus
so anyway,
Christ.
This angle of vision was the same than if you keep one eye, your hand like this, and if you look from the hole of this needle.
Okay, so I have a needle in my hand. And
it gives you
hold it, and I basically with my stretched arm, I want to look through the hole of the needle. So
this angle, what you have now between your eye and the hole of the needle.
Yeah, that's a second dark.
No. This is more or less what Hubble did.
Okay.
What we call today Hubble deep field.
Okay.
For weeks he was focusing on this place, and just focusing on this place, he could find billions of stars, supernova, galaxies, and stuff.
Yeah.
And in this picture, very famous today, called Hubble Deep Field, there is even a remastered version called Hubble Extra Deep Field. I mean, there is several versions.
Okay.
If you want, not on this computer, maybe on this one, I have the full version, what you can download for the NASA, a picture of 25 megabytes. And anyway, on this picture, you have very interesting stuff, which is a galaxy, which is so far that this galaxy is just 500,000 years, more or less, after the Big Bang. You understand? 500,000
years?
Yeah, this galaxy is born
wow.
when the universe was really a baby.
Wow.
And we can see it because it's far. Just to say, even Hubble, who have been built in the 70s, can see it. And you know, now we are developing a new telescope, the James Webb Space Telescope.
No, you mentioned that before.
It's my dream. I mentioned to Lutza for 2 years. That's years I'm waiting it, but it's always late. Fortunately, they're late. This is interesting, Boyd. You know, Hubble is just at few hundred kilometers from the Earth.
Yes.
But you know, the James Webb Space Telescope will be much more far. It will be in a Lagrange point. It means in a point of equilibrium between different gravity.
How far it will be?
I don't remember, but it will be, I don't know. I know it will be in a Lagrange point, just I don't remember if it will be the L2 or Hubble Deep Field. Deep Space Field. Champ profond de Hubble. Yeah, you see, you have it directly. Yeah. So there is a HDF and the XHDF or XDF or something like this as well, which is modified.
One, two, okay. Yeah, my friend sent me a photo. Maybe it could have been this one. He said it was put together from like multiple of images, and it was beautiful.
Maybe it's this, but
maybe it's this one.
Like I said, you have many. You have some pictures who take the whole field. You have some pictures who take just a corner. You have a bit of. Of course, it made many pictures, but the basic one, like I said, you can download it in a TIFF format from the NASA website.
Yeah, that's huge.
This one I see started to be big, yeah. But it's not so big definition. So anyway, maybe you know it. More you see red, more you see far.
Okay, no, I don't.
You know the acceleration of the universe, is accelerated.
Yes.
You know,
the expansion is speeding up.
Yes, Einstein was wrong about it. He corrected himself. But Einstein, first, he thought it was no acceleration.
Mm-hmm.
So he was wrong the first time. And when he thought it was an acceleration, he said, oh, then if there is an acceleration, then this acceleration is slowing down. Oh, acceleration, expansion. If the universe is in expansion, then this expansion is going down, the speed of this expansion. Mm-hmm. And he was wrong a second time because finally it was accelerating. And that's why there is something added called constant cosmologique. When you check the main part of the Einstein expansion, there is you need to add something at the end of the equation to compensate the expansion of the universe and the effect between objects. So because of the expansion of the universe, which is accelerated, more an object is far, more is going away far from you, and fast, because it's more far.
Yeah.
You understand? More you see far, more you see through the time. Mm-hmm. And I don't know how I can explain. So anyway, the objects who are very young and far, they appear red because of the Doppler-Fizeau effect. Okay. It's very funny, but it's the same effect. This is very easy to explain. It's the same reason when you listen a car or motorbike going through you, it do.
Yeah.
The frequency
That's the
change.
Doppler effect, isn't it?
Exactly, yeah. The frequency is different. Yeah, this is not the Hubble deep field.
No, it's not. It's just, I wanted to show you this. My friend sent me 1,000 hours of exposure.
Yeah, but that's my problem.
What? Now you're gonna talk about the black hole.
No. It's not a problem. Well, like I said, I have it. It's
beautiful. It's like a painting.
Yeah, but I start to be disappointed because the problem is the difference between. You want a metaphor which is totally connected. You will, as usual, you will think I change subject, but I don't. Would you be happy if the CGI for Marvel movies would be so perfect that they would be totally invisible to see if it's CGI or real? Would you be happy? If we become so good in CGI that it becomes impossible, exactly, you couldn't totally...
Would I be happy?
Would you be happy about it?
That's a silly question, I don't know.
It's the same question about it.
Tell me, explain.
Actually, we are happy because...
This is the photo enlarged.
Yeah, in this example, this is much closer than this.
Gotcha. Mm-hmm. Look at this. These are... Oh my god, this is beautiful.
Mm-hmm.
That's unreal, huh?
Yeah.
And this is like, one of these is our Milky Way, right?
Yeah, exactly.
And there's like thousands of them.
Yes, except not all of them are different. Some of them are galaxies, some of them are supernova, some of them are...
Dude, I mean, it's so scary if you think about it. And this was just one tiny...
Yeah, this is what I said earlier about this angle.
Look how big it is.
Yeah.
It's insane.
Yes. After this, we can speak about the existence of God, because many times I try to... you see this?
That's a good
subject. You do photos, so you should know what is this.
Looks like a friggin' sun.
You see this? Yeah, because it is.
Okay.
And it's much closer than other stuff. But you see this...
the halo effect?
Yes, exactly.
Yes.
This is because of Hubble. Because Hubble uses a glass system. When you use a system of mirrors, you don't have this. Maybe you know it from your skills of photography.
Okay, tell me again. So
there is people who prefer doing astrophotography using a telescope.
Yes.
And some people who use what we call a glass, something with mirrors and something who focus the light like this, and you check on the side.
Yes. Yeah.
Or a tube, and you check at the end of the tube made of glass.
Yeah.
So it's you can combine the two technologies. It's what we call a casse-grain, for example, a type of telescope. But when you have something made of mirrors, you don't have this. This comes from the glass.
Okay.
So because it's Hubble who did it. And Hubble is a system of glass.
Look at the mess here. And even there, there's little dots in the background as well. They could be the same stuff but further, no?
Yes, but the universe is built as a sponge. It means there is like holes and fibers. You know, it's like
Wow, this is
It's the logic of gravitation, of course. Objects attract themselves each others.
Right.
An object have no reason to stay alone usually because he will be always attracted by something else, etc. Okay. Yeah.
Beautiful.
So here we spoke about some alien forms, and it's a big subject of conversation with my girlfriend, this, for example. And these two aim a bit against the main theories.
So what about God?
For me, all of these questions are connected. Existence of aliens, existence of God, and the shape of the universe. If one day we can know if the universe is finite or not, finite, I don't say have an end or not, yes or not. Like I said, it's a semantic question as well, because if we admit the universe have an end, the word universe means all what exists. So if there is an end, even after this end, even if it's quantic chaos, this quantic chaos will be called universe as well. You understand? So that's why saying the universe have an end, it's a paradox, because the universe by definition is all what is.
Yeah.
So never ending, but you know what we speak about when we say have an end. It means no more planets, no more stars, just empty
dust or whatever.
Yes, exactly. No, even dust, even no gas, nothing. The chaos. So absolutely emptiness. Even no blood, dark matter, nothing. Or it finished like this. You have less and less energy, less and less photons, less and less waves until you have almost nothing. Or it's like some people say, like you come back on your point. We call it univers bouclé.
Okay.
These two.
Back to the beginning.
Yeah, exactly. Yeah. Or you have like, this join a bit the theory des Brahms, same theory from Hawking, so bullshit. I'm kidding, of course, he has some very good theory, but just like I said, he has this bad habit to try to prove he's right instead of trying to prove he's wrong. But he's not so sure. In his books, he doesn't say, oh, I am right. Huh? But he tried to prove his theories more than he tried to break it, and this is a problem. And is this kind of people who trust the universe is like a tissue who can sometimes go back on himself in one of his theories, not all of it, because he have different theories, of course. And these two, I don't agree with it. Because this is a side effect what you can have when you imagine the universe in 3 dimensions. Yeah. That's the problem what you have. And the other problem, it's we have to admit we will never have the answer of this, because how can I say, if the universe is a ball, so what is outside of this ball? The problem is we cannot have answer of everything. An easier way to understand that, it's not to see in big, it's the opposite, to see in very small. We discover the atom. Atom come from Old Greek, it means you cannot be cut, insécable in Latin. The translation of atom in Latin would be insécable, impossible to cut. Atomos, you cannot cut it. But in fact, yes, you can. That's what we do in the nuclear stuff. So yes, you can cut the atom technically. At a cost of a big energy spending, but you receive back a lot of energy as well. So in energetic, it's very interesting to cut the atom. Dangerous as well, but energetically interesting. So we can cut the atom. Yeah, I know. And we discover there is something inside the atom. And now we know there is something inside the electrons as well. There is always something inside. You understand? Imagine we discover, for now, one of the smallest stuff we discovered. We cannot see it again because it's under the vision. So you cannot even see it with... even if we continue to develop microscopes, even in 1 million years, we will be impossible to visualize an electron, because an electron doesn't have visuals. Yeah. Because to have a visual, you need to have a skin, something to reflect the light. How you can reflect the light if yourself you are smaller than the photon? You understand? An electron, I don't know the size of an electron compared to a photon, but it's the same kind of microparticle. Not same kind, but So it's not something what you can imagine as a ball and something visible. That's why, like I said earlier, I imagine something like a cloud. It's easier to imagine like this. An atom is like a big cloud, and inside this big cloud there is a central part, another cloud, with clouds turning around, and they are in an undetermined position. Yeah, because these two, they teach you the slice of the electrons, the positions.
What's that? I'm missing a word here. You know, I was reading about the book about the observation of the electron, and you know, when you observe it and you don't observe it, it behaves differently.
Principe d'incertitude? Heisenberg?
I don't know.
But what you want to know? The name of a theory? The name of a guy?
No, I wanted to bring up the subject because it could connect here that...
the spin?
No. I'll tell you in a second. I just need to remember. I'm missing that word now. Bloody hell.
Invariance CPT?
No.
CPT?
No. No, it's more common. And that's why I wanted to bring it up, because I wanted to hear your opinion on it.
The fact you cannot measure the position and the speed of an atom?
Yeah, the electron, how the electron behaves when they made experiments, and the electron behaves differently when you actually observe it, how it behaves.
Yeah, and yes, when you block the spin of an electron observing it, if these electrons come from an atom, and if you have another electron who come from the same atom very far from here, this other electron very far will always be connected with this electron, and the connection between these two electrons will be faster than light speed.
Mm-hmm.
But this is not same. It's a problem. It's not faster than light speed. Nothing is faster than light speed. But the reaction between both will be instantly, even if they are very far from each other. So of course there is an information who go faster than light speed. But this is a problem, like I said, of visualization, because we imagine the universe as something flat. If you imagine, instead of having an information who go from here to there, if it's the universe who who fold himself.
It's just...
Yeah, exactly. So it's
that's why you're thinking in 3D.
Yes, exactly. That's a problem of thinking in 3D, like I said. It's always a problem. It's like sometimes these two, I say this sentence to many people. It's like trying to imagine a color what you have never seen. You cannot. You can mix some colors in your head, but you cannot imagine a color what you have never seen.
Exactly.
How look like the infrared? You cannot imagine it, because we are not able to do this. And I try to imagine the same.
The same thing applies to, for example, movies, to sci-fi movies, because in sci-fi movies it looks like it's sci-fi, but it's really nothing new that we haven't experienced so far.
But we cannot. It's impossible to see. Our eyes are not able to see this. Yeah. So I think that's what we were speaking about, these atoms who are maybe interconnected. But
I'll tell you in a second.
Intrication?
No.
Because the fact that they are connected, we call it intrication quantique. There is a fact when you check an information, this information is locked. While when you don't check it, Schrödinger, the cat of Schrödinger, no, another connection with this.
No, it's not a theory like that. It doesn't have a name like that. It's more. It's like. Anyway, we can move on.
So anyway, all of this for me is connected. These questions about how is the universe and if there is a God.
And how is that?
This I don't know, because like I said, I don't know if there is a God, but all of these questions, they are connected in my case, in my opinion. Totally connected. Yeah. Because if there is a God, is necessarily out of the time. But in that case, that God will be out of the universe time. When the universe will crash down in 40 and something billion years, what will happen with the God if there is a God? He will crash down as well, or he will survive to that? If he survives to that, it means the universe is not infinite. because this God need to be out of the universe to survive to this end of the universe. So it means the universe is just a part of a bigger stuff what we don't know yet. You understand how I can connect both? If the universe in the opposite is infinite, then there is no God, because God in that case would be old or young. But if the universe is infinite, then God is inside this universe. And then it would mean God will have a birthday and a death day. You understand? And when you are in a situation of time, you cannot travel through time and you cannot see different time in simultaneously, like God should know. You know, God have no time and no place. Is out of our system. To be out of our system needs to have some limitations. That's why if one day I discover we know the shape of the universe, then I will know if God exists or not. For now I don't know, and I think I will never know, but for me these two questions are interconnected. Like I said, it's a personal point of view. Like,
it's interesting.
But honestly, you have many scientists who don't think scientists, they don't trust in God, etc. It's many science questions involve a bit the existence of something bigger. Because it would help to reply to a few questions. But the problem is, like I said, we will be never fully satisfied. If we discover the universe have a shape, then what is out of this shape? Okay, we would call it universe, but this is semantic. If we forget the semantic. If we discover, if you travel always straight, there is like a wall. What is behind the wall? If there is nothing, okay, there is nothing, but what happens if I send a spaceship in this nothing? The spaceship will travel in the nothing, and after he will find another universe, or he will crash down, or he will come back to the same point. What will happen technically? And all of this, I think we are not meant to know it. We cannot know it, and even if we know it, then it will be other questions. Like I said so many times, if we discover we are in an aquarium, then the question will be, who is looking at us? Then it will be what we call our God. But this God who will look at us in an aquarium, he will be in something. How will be the shape of this home where he is? You understand? If this person, if this God, if this stuff which is out of our universe is out of the timeline, because of course he's out of our universe, so he's out of our, you know what we call time is just sensation, is just feedback what we receive because of the cause and consequence. A cause creates a consequence, and a consequence cannot act on the cause who gave him birth. You know, it's a law of physics.
Okay.
You cannot go back through time.
Yes, I understand.
A cause provoke a consequence, but you cannot go back from the consequence to the cause. And
only one direction.
Yes, exactly. That's why it's a mistake. Because it's we speak about direction, many people imagine the time as a line.
Yeah.
And that's why there is many movies who say, yes, the timeline.
Yeah.
And many people say, yeah, but imagine you have another line, or imagine you have like this, a turn. All of this is bullshit. And it's a fight with Lutza. A fight to tell her, stop to imagine the universe in 3D, stop to imagine the stuff who are balls and turning around, like the atoms, and stop to imagine the time is a line. Time is just a human feeling of the cause and consequences, of the interaction of what exists. If there is no interaction, then there is no time. So that's why if there is something out of our universe, then this stuff is necessarily out of what we call the time. Because the time, it's our sensation to the cause and consequences. But if somebody is out of our universe, is not subject to our system of cause and consequences. Something out of our universe would see our universe like an object. He would see the past and the future in the same time, what we call time. You understand? No? You said yes, but it's...
I understand, yes, I understand. It's just, like...
Now I say...
brain fuck.
What I say is, I'm just saying is that it's impossible. That I don't say that time travel is impossible. I say the time travel even is stupid. I don't say it's impossible to travel in time. I say travel in time is like if I say travel in my finger or travel in a color or I don't know.
Okay.
I mean, even if I say travel in my spoon, you can imagine going from the left side of the right side of my spoon from the inside. So even this you can imagine. But if I say to you, okay, travel inside the red color, you will say, okay, but red color is not a place. It doesn't have a dimension, so you cannot travel inside. And time is the same. Time is not a dimension. It's not an arrow. That's why I always, when people mention the time as an arrow, as a line or arrow, yes. Because it's very dangerous to imagine like this. I understand.
So how do so now what comes up in my brain? How am I supposed to imagine it then?
Like I said,
it's really
it's what I do in my head. Like I say, it's very me in my head. I imagine, like I said, I imagine the atoms as cloud, and the time I imagine it not as a place, but just has cause and consequence stuff. So I don't imagine it with something visual in my head. I just imagine it as an equation. This plus this equals that.
Okay.
1 plus, let's say 1 plus 5 equals 6. But you cannot go from 6 equal 5 plus 1, because 6 can be equal at 4 plus 2, or 3 plus 3, or 3 times 2.
Okay, I'm catching that, and?
Or 6 times 1. But you can go in one side, but you cannot go in the other side.
Okay, yeah.
You have the cause who make the consequence, but if you try to go back, the same consequence can be provoked by different cause. So you cannot go back from the 6
understand.
To the what is back.
The last example you said is completely clear.
And,
I understand. It's just how am I connecting that or translating it to time, to understand time. That's why I'm just...
Because I imagine time like this. But like I said, it's just a way to make it in my brain, because our brain
I understand. This is just
can
your
only
point of view.
works. Our brain can only works with what he knows.
Yeah, so...
Which is the 3 dimensions, the spec, the visual spectrum, and what you do is what you can touch, what you can feel. Yeah. So with your sensations. Our sensations, they are limited with our eyes, our ears, and our brain.
Yeah.
So we are limited in terms of dimension, of energy levels. We are limited in many ways, and we cannot imagine out of this.
I'm just thinking, what if in the schools, in elementary schools, you have some sort of educational classes where they leave these things open. They don't say biology and mathematics and this and that. You know, they don't put you into boxes. And they have some sort of education where they leave this open, that, you know.
Yeah, but my way to think is due to the fact, like I said, I have this brain stuff.
Right.
Guy, I don't think it's a quality. Like I said, the English name is low latent inhibition. It's a weakness of something.
Understand.
And I think I'm able to do like this because when I was child, I was very special at school. I was sometimes very good, sometimes very bad. It was no middle for me. I was very, very good even in terms of result, you know. Some kind of result, I had the best mark. Sometimes I had the worst mark of the classroom, because sometimes it was out of my way to work, and the other stuff is at school I was unable to focus on something. I could never focus on something because, like I said, imagine when you're in a classroom, you have to do an exercise, but if in the same time you are thinking about, it's sunny outside, my brain couldn't stop to think about the sun or about many stuff.
I understand.
And that's why you can feel I change subject many times in my conversation, because in my head, I'm not changing subject. I keep every part of the conversation in a piece of my brain.
You always come back and I crack. 20 minutes later, you come back and it becomes a circle.
Yeah, exactly.
Yeah.
Because everything is connected. All the universe is connected. We live in the same box. So whatever we speak about, there is connections. And that's why I have patience in politics as well, because politics is the same. You evaluate the today's parameter to know the result about tomorrow. It's the same about causes and consequences. You can do a lot of statistics and calculation and probabilities and evaluations about politics as well. So that's why I like it as well. And for the same reason, I like to repair many stuff. But it's what you said about school. Honestly, I think in my case, I learned to think like this, and I realized in my case it helped me. Since I tried to explain science with Lutza, I realized I did with other person like my father, and it helps them. It helps people when I say stop to imagine the 3D. Keep in your brains and all your models are just models, but they are visually wrong, and the line is not and the time is not a line. This kind of stuff is useful. It's like you keep the visuals in your head, but on this, like I showed you in the kitchen, in the side of the visual, you have like an arrow saying this is just a visual, this is not true. And like this, when you keep like this, is good. But at school, I'm not sure it would be wrong, because if they would teach me wrong, I mean, I think it's wrong. Imagine at classrooms they would directly teach me, okay, the atom is not a ball, and the electron doesn't turn around. Yeah, because the electrons, they don't turn around. Because if they turn around, there is a moment is here and a moment is there. So it means there is a position for the electron. If there is a position, it means there is like a wall of the electron. Yeah, because now I'm outside the electron, and at the moment the electron comes in, I'm inside the electron. So it means, of course, there is a moment of existence and a moment of non-existence at each point. Which is not good, because the electron doesn't have walls, doesn't have limitation. It's not object. So it doesn't have a defined position. That's why an electron can be at different position in the same time. That's what you were thinking about earlier as well. The fact an electron and the microparticles can be different position in the same time. It's something proved by an experience called the cat of Schrödinger. But it's that's why I prefer imagining like a cloud. You know, a cloud which is all around the center of the atoms.
What physics? The word is some physics.
You still try to remember that word?
Yeah. Fuck, it's so common. It's just I don't remember.
You cannot check it?
Physics, some physics. And it starts with letter P, I think.
You said in French we say principe d'incertitude, or...
No, it's more common. It's like when I'm gonna say...
Prédétermination?
No. Physics. Jesus Christ. And I read a book about it years ago. Fuck.
I cannot.
That's terrible.
Sorry. You cannot check it?
No, I tried searching it, but...
Okay. So yeah, I'm not sure at school it would be useful to teach like this, because maybe it would confuse more than helping. I think it's useful at the beginning to imagine it like a ball. I'm still in this example of the atom. And after, when you grow up, you can put yourself out of these limitations. One thing I know, it's if there is aliens, then there is not a lot.
Quantum physics.
But it's not...
That's what I was reading about.
But quantum physics, we said many times. Quantum physics is... I told
and
you 10 times.
That's what I wanted to ask you about. Tell me.
No, go on.
No, carry on.
No. It's
I don't have a full question, but because now I'm happy that I found the word, but I don't know what I...
But we mentioned several times this name, quantum physics. Like I said, quantum physics... So. The name... Yes, I said.
Did you?
What we call quantum physics sounds, technical, is nothing technical. Quantum physics is just putting in mathematics what is inside the atoms regarding the 4 big forces of the universe.
Yes.
The problem is actually we just have 3 of the force. Like I said, the weak nuclear force, strong nuclear force, electromagnetism. But we still don't have quantum physics for the gravity. This is what I told you earlier. So technically, that's the difference between a théorie de la relativité restreinte and générale, the 2 main Einstein theories, one trying to involve this and not. But even the one who tries to involve the gravity, it works, but it still doesn't explain how it works and regarding inside the atom. So what we call quantic. Quantics refer to a certain quantity of datas who are not determined by numbers. Like I said, an electron, for example, we have a number on the side. You know, for example, the helium, hydrogen, they have one electron. Yes. Hydrogen, one electron, helium, two electrons. But if you would cut an electron into parts, not an electron, an atom of helium into parts, you would see two balls inside. 2 is a number of energy what we decided to give to this, called the nombre d'Avogadro. C'est connu. It's now in this name, Avogadro. We learned it in high school, this name. So it's an amount we give. But it's our mathematics who allow us to give this number. But it doesn't mean this number is an exact number like 2 pieces of pizza. You understand? It's again, it's like a metaphor of what is the truth. The truth is it's not an object. So it doesn't have a determined position or determined quantity.
This is what hard to grasp for the mind.
Yes. And it's
after physics.
Exactly.
Class.
I say what I said earlier, but in a different way. You can be better in physics if you stop to try to visualize. For me, in my head, I was not saying I have the universe in my head in 3D. No, I'm saying I keep the universe in my head, but I put a big arrow saying this is not 3D.
Yeah.
And now I can show you again, you will think there is no connection. Do you know what is a tesseract?
No.
You can even think about the Marvel movie if you want, because it's a bit connected. The tesseract in the Marvel movies, yes. A tesseract, it's a cube, but of 4 dimensions. Okay. Have you ever used a program called SolidWorks or CADWorks?
CADWorks? No, is it a drawing program, right?
Yeah, exactly.
I use Google Sketch. Yeah, we have about 25 more minutes.
Do you want to keep the 25 for more exact questions?
No.
Okay.
I like what we're discussing.
Okay. But like I said, I can focus on one question if you ask me to focus on one question point.
No, just go with the flow.
And but this is connected to, like I said, to this way to understand the universe as well. Because same, we work in just 3 dimensions. I think the universe has 3 dimensions, but it have we imagine like 3 dimensions. You understand? Now I strange subject, I admit, it's totally not connected, but I prefer warning about it, because some people know it, but some people, they don't know it. Do you know, even if we go at the other side of the universe, it's a paradox, because we don't know if it's but imagine we go very far in the universe, we always still have the same elements. Do you know that or not?
Are you asking me or asking?
Yeah, I'm asking you if you know that.
We always have the same elements.
Yes.
Such as carbon and neutron, nitrogen.
This Mendeleev periodic board is not for Earth, it's for the whole universe. All of the universe have the same elements. Not in the same concentration.
Yeah, I got it.
For example, a star is full of hydrogen at the beginning, then helium, then blah 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 blah, until the iron, Fe, Fe. But after this, nothing can be created by stars. It have to be created by something else. No stars in the universe do more than the Fe, iron, Fem in Hungarian.
Yeah.
The Fem is the limit of what the stars can do. After you need other objects, like a pulsar, other stuff you can do other material. And after, all of these microparticles who will create heavy atoms, they are pushed away by the what we call the wind of the suns, of the stars. And we receive literally what we call stardust. And the stardust with billions of years creates planets, creates atoms, creates elements. And then it's refocused to the core of the planets due to the gravitations. And that's how the planets exist. So, and
that's how, for example, Earth became about?
Yes, except Earth, it was not dust and suddenly a big planet. It was first many asteroids who, it's small and bigger. It's like the human evolution. We were one bacteria, then one day we had a little stuff who looked like hand.
Imagine how long it took, man. Like it's ungraspable.
Yeah.
For the mind.
Yes.
Ridiculous.
But wait, yes.
How did the moon came about? How is it so round?
Yeah. To come back to the subject, what I was saying.
Yeah, tesseract.
I will say because again we do a paper, but it's audio stuff.
Yeah, I'm gonna tell what you're drawing. So you're drawing something.
Yeah, it's very logic, and of course, if somebody knows science, even before I draw, they know what I will draw. You know, because what I show you, it's a classic way to help students in science to understand something.
Show me.
We are in 3D, but we can make a draw in 2D or 3D.
Yes.
If I want to draw a square, I draw a square. When you use a program like CADWork, when you want to make a cube, or SolidWork, which is very common, like the program what you said, you make a square, you choose your dimension, then you go in the options and you choose the option in French, I don't know in English, extruder. It means give one more dimension.
Yeah.
And then your cube become like this. Okay?
Has a body now, it's became a cube.
Yeah. So this, technically, what is 2D or 3D?
Well, it's, Good.
You understand? You understand? Yeah. You don't know what to write?
Yeah.
Technically, it's 3D, but no, it's 2D.
Yes, correct.
In 2D, I draw 3D.
I understand, all right.
Imagine there is another dimension.
Yeah.
It doesn't exist, but in mathematics it exists, because it's useful sometimes to go in a fourth dimension, then to come back in the 3 dimension. It's very useful for physics and mathematics joined together. Okay. Even if we know this dimension doesn't exist, it's like in mathematics, derivative and primitive. You know, but anyway, it can be very useful in mathematics. It's not just a toy. It's very useful what I'm saying in mathematics.
Okay.
Same for a round. A round in 3D become a cylinder. You know, you have a round and you add a 3 dimension, it become like a tube, a cylinder, which is full.
I understand.
Okay. And what's happened if I change this and if I add one more dimension? This become a sphere. You know, with the reflect of the light, I don't know how to draw a sphere, but you understand? This become a sphere, and this become what we call a tesseract. Okay. It means you can draw in 3D on a computer a program. No, you don't draw a program. You use a program to draw a cube, and then you move your cube into a fourth dimension.
How?
Of course, our eyes cannot imagine, because us, we have this 3 dimension just like this. So you cannot imagine except one more in diagonal, but the problem is that diagonal is just a mix between this one and this one.
Yes, exactly. That's why I'm asking.
Yeah.
Like,
so
what's next step?
Because we cannot, that's why I say it's useful this, because you have to try to stop to put yourself in the 3D. It doesn't mean you can visualize it, just you have to forget the visualization. You have to admit, okay, it's like this, without any visualization, and you keep like a black hole in your head, and you say, okay, this black hole is a tesseract, is my cube in 4 dimensions. I cannot see it in my head, it's normal, my brain is not able to see it. What you can see, it's a draw in 3 dimensions about it. So now I cannot show you on a paper because this paper is 2D.
Yes.
But with a simple computer program, I show you how look like a 3D tesseract, which is a draw in 3D of something of 4D. Always by drawing you can reduce a dimension. Right. We know the 3D. Like I said, this cube, I can perfectly show you a cube of 3D in 2D.
2D. And you
so I can perfectly show you a cube of 4D in 3D. Yes.
Really?
This cube, if you see it in 4D from the front, it's like a square, but with diagonals like this.
Gotcha.
Okay?
Yeah.
But when you turn it, it doesn't turn logically for our brain, because our brain is like this.
Like inverted?
Yeah, these outside lines go to the inside. It's a bit... If you just write tesseract on Google, you will find many pictures who show it on different angles. A tesseract have different visuals because, of course, it's like a cube. Yeah. This cube in 3D, if you look at it from perfectly face, even if it's in 3D, you will see just a square.
Yes.
Like no. Yeah. If I show you this glass from here, you don't see a tube. You see just a round.
Yeah. Exactly.
But you see in 3D. But because you see just a face, so it's it depends on your point of view in the 4 dimension. And this tesseract, it's a good example about how something can perfectly work but be impossible to visualize by the human brain. So it's I don't trust there is a 3 or 4 dimension in the universe. Just I say the universe have laws what we are not able to visualize. We can calculate it, we can understand it, but not make a full concept about it because we are inside. So we are limited by our sense. Our sense, who are 3 dimension, just a spectrum of color, just a spectrum of what we hear, of what we touch. Yeah, because look, we don't feel the air, but air. There is same quantity of atoms here than here.
Yeah.
Why I can cross here without feeling anything, and here I feel anything? I feel something.
So what are we looking at?
All of this is tesseract. You see, this is the main view. But when you turn it, it becomes a bit like this. So something what you don't understand. But now you picture. If you look at a video, when you go from there, it's just a turning.
Okay, I understand.
You see, this is a development. You see, square, cube, tesseract. I told you when you write tesseract, you have many stuff like this, and that's why in the movies Marvel, this tesseract is a cube because it's a cube, but who hold another power, like another dimension. I don't say Marvel is smart movies, but.
Do you see the new one?
The Endgame? Yeah.
There's some time travel shit in it, and I didn't want to bring it up while you were talking about it because it's not.
Yes. But like I said, there is people who say, "Oh, there is good movies about time travel and not good movies about it." Every movies are necessarily bad because, like I said, we don't travel in time. Time is not a dimension.
That's what was my conclusion when you were talking about time travel. That all movies are bullshit, basically, because they all explained on the timeline.
Yes, exactly.
Yeah.
It's a mistake. But I don't hate it. For me, I really like Back to the Future. I love it.
I really like time travel movies.
It's
because people like fantasizing.
Yes, exactly.
Time travel.
Exactly. Just we have to really forget it. To really keep in, like I said, a big arrow saying this is not real.
Yeah.
This is not.
That's interesting.
Yeah.
Wow. So what's the deal with the black hole photo? Or is it a huge subject and you're not gonna finish it?
No. It's
15 minutes?
funny. No, because we spoke about it in another way. I told you I'm a bit disappointed because you remember when I used the example about the CGIs.
Okay.
Would you be happy to have a movie so well done that you even don't see the difference?
Yeah, and I couldn't answer.
Would you be happy that we don't need anymore Tom Cruise? We recreate Tom Cruise in 3D and we have a Tom Cruise actor perfectly visually, even if he died 10 years ago. Would you be happy about it? Where will be the talent? Where will be you understand?
Yes.
We like when we look something to know it's real.
Right.
You understand?
Yeah.
That's why, for example, many people, including me, like the Fast and Furious movie. Because even if there is CGIs, they try to reproduce maximum of stuff what they can, keeping the security of the actors, of course, in real. For example, in the 5th or 6th Fast and Furious, there is like many cars who fall down from a building because they are controlled.
Yeah.
No, it's later because it's with Charlize Theron. It's maybe the 7th or the 8th.
I know what you mean. Yes, I know.
It's maybe one of the latest one. I think even the 8th, when the cars fall down.
Yeah.
They rented a building, they rented a street, they installed a big iron layers on the ground to protect the ground, not to hurt, and they threw cars. You understand? Of course, after they added some CGIs, but they didn't create the whole in CGI, they threw reality cars because you feel it's real. And we like to have this feeling it's real. The problem is, if your eyes cannot see the difference, what will be your feeling if you don't know what is real and what is not? And now I come back to these pictures. The picture of the latest black hole. Yes, exactly. Picture. And the picture of what we saw earlier, like the galaxies far with a beautiful cloud, blue, purple, you know, these beautiful colors when you see on beautiful picture. It's pictures who are recreated by computer about how it would look if you would look. It's like a CGI. So in that case, sorry, but I prefer 10 times the picture of the black hole in Interstellar than this picture what we had a month ago, or 2 months ago.
Why?
Because it's more beautiful to see. It's bigger on the screen.
I understand.
The definition is bigger.
Because for you it's the same.
Both of them, they are
created
exactly
image of the black hole.
So I don't care if they say, yeah, but this calculation is based on something what we know and this one not. Both of them is pre-calculated by a computer. Mm-hmm. Both of them.
Have you looked behind how this image was made?
Yeah, in fact, I don't say it's not interesting. It's very interesting. The point is, it's interesting for what they will discover in maybe 20 years. Actually, it's nothing. But of course, to have money, to continue to make the science, actually we live in a bait-click world. You understand?
Right,
to have money, you need to make...
Yeah.
You need to be on the first page of newspapers. So that's why, oh, look, the first picture of a black hole. No, we ever had many of this kind. We have many studies about it. We have ever people who made, okay, we have a black hole here, and we know this star does this, and we know this star does this. So of course, this black hole is supposed to be there. It should be this big, and this gravitational effect, so is this. We even did it with when you turn a telescope into the center of our galaxy, which is not so easy because you have many interference because of the other stars and stuff inside our galaxy. More you target the center, more you have a density of stars. But when you check the center of our galaxy, you cannot see the center because it's a black hole, but you see what is around, which is star systems, you know? And you have, when you visualize in a regular time lapse, you have a star full of planets who approach the center of the universe.
And it disappears, or?
And then it do like this. Follow my hand, this one. Slowly, slowly, and boom, accelerating and slowing down. Accelerating. Accelerating. It's make an orbit, elliptic orbit, and when it go closer to a certain point, it accelerates. So you make a draw about an elliptic stuff like this, and when it's here, it accelerates.
Understand.
Then you check another solar system, it's like this, and when it's here, it accelerates. Then another one like this, and when it's here, it accelerates.
Create a shape.
So of course you start to realize, oh, there is something very massive here who create a fucking acceleration what the humanity cannot imagine. It's like half of the light speed, you know. I exaggerate, but you can imagine it's very, very far. And so now, if I use a mathematical calculation, and now I'm just imagining what I'm drawing to you. It's not a plan. So to show you, it's not so hard to understand like this. I just need to take a computer, calculate what is the acceleration of these different stars here, to calculate the size and the difference of gravitation between this part and this part and this part at our point of view. And I can redraw if I want. You know, with a good computer, just with these parameters, I can draw a black hole. Of course, we won't see the center, but we see the effect of it. Like this picture of black hole, you see a dark circle, and around you see many lights. With this corner here, the down, with our point of view, the down left corner, have like a bit more light than here. It's because behind, it must be a solar system or a galaxy or something very lightful, which is a bit more to the left side. So of course, the light arrives and turn around it. Okay? Rayon de Schwarzschild, this is another stuff. So the light is derivated around due to the gravity effect. And you have more light who pass through this side because maybe this is a bit more to the left than to the right of the axis of this.
Interesting.
And what is interesting, in fact, is not this picture itself. What is interesting is how they did it. They received informations in different spectrum, so not only the light, the infrared as well, the magnetic as well, many stuff, because to attract all of the information what you can get from there. And we have the Earth planet there, much more far than this, and they didn't use one telescope or one, to get an information, you don't need a telescope, you need a
radio.
Yeah, something like this who grabs, radio stuff.
Those massive satellites.
Exactly, because the telescope just receives the visual spectrum of the light, but we can receive many stuff. The radio, like you said as well. Okay, so they use many stuff like this. Actually, we use many. We have a very big one, bigger than Hubble, who will be in space maybe next year or in 2 years, the James Webb Space Telescope. But now there is something, I forgot the English name for this, they don't use only one, they use many on the planet. They accumulate different origins of information. And they say this black hole is like if it was a picture took by...
these giant satellites that you see in the movie.
Like the Arecibo, yes. Like in the GoldenEye movie on X-Files.
Yeah, or the... what's his name? The other movie I really like.
Interstellar? No.
No, Interstellar with Jodie Foster.
Oh, Contact.
Yeah.
Yes. You can use many of them on different positions on Earth. And accumulating the information of all of them...
You get an accurate picture.
You get a picture. Is that why they say this picture have been taken by equivalent? It means it's like if it was like this, parabole.
Yeah.
Big, like 100 meter large or 1 kilometer large or something like this.
Because you accumulating the signals of all these satellites on the globe.
So it's like if it was one...
using like a kilometer wide satellite and getting the information through there.
But like I said, where is the real... What is the limit between what is real, what we calculate, who look like real? You understand? I don't have an exact answer of this, but anyway, this picture for me is not amazing because I know it's calculated, so it's like a CGI.
Right.
Even if it's realistic, it's a CGI.
Understand.
But the problem is my fault. Yes, it's my fault and the fault of the humanity. It's a problem of the humanity should think now. We have to change our vision about what is real and what is computer made. What is original, what is computer made. Because even what we see is not what we see. You know, we see in an opposite way.
Yeah.
And it's our brain who makes the stuff back in the right way.
Yeah.
Our eyes, they see in the wrong way.
Yeah.
It's our brain who puts the stuff back.
Yeah. That's very interesting.
You understand? Even what we see, it's
not true.
Yeah. So that's why we really have to think with this picture of the black hole about what is real, what is not. But it doesn't change the fact what is interesting in this black hole is not the black hole itself. It's interesting as well, it's a way to prove to the big audience the black hole exists. But like I said, we even know now there is one at the center of the galaxy.
Yeah.
Not Gargantua, I'm stupid. Sagittarius A.
Sagittarius.
Yeah, is the name of our black hole at the center of the galaxy. Which is supermassive. A black hole is always big, of course, compared to a planet. But the black hole at the center of the galaxy is way much bigger than all of our solar system. Way much. It's we could fit maybe 1 million solar system inside. You know what I mean?
Whoa.
No, maybe I exaggerate. Oh, not so much. Guy, I don't know if you realize, but just Jupiter is 1,000 and 1,000 times bigger than the Earth.
Yeah, I know that.
The Earth is 6.5 and 3, let's say 13. The diameter of the Earth is just something like 13,000 kilometers. 13,000.
Yeah.
Just with my car, I did more than 300,000 kilometers just in the last years.
I know it's ridiculously small if you're looking at it this way.
And just Jupiter, it's more than 1 million kilometers. More.
Yeah, it's huge. Like when you see those graphics online, you know, when you have the planets like real size.
Yeah. You see
ridiculous.
how. Yeah.
It's ridiculous.
So imagine a black hole, even not a supermassive. So imagine a black hole who hold, by its power of gravity, all of a galaxy full of billions of stars, billions of solar systems like ours. And you have one black hole at the center who have the gravity strong enough to keep everything in rotation. It's we speak about object. If it's hard to see, it's because it's invisible. But if the black hole was making light, we would see just this in our sky. You understand what I mean? Because even if it's very far, it's very small, the intensity of this power, if it was in terms of light, of course it doesn't send light, a black hole, it attracts the light.
Yes, yeah.
But if a black hole would send light, it would be a small point in our space, but this small point would be so brightful, like it would, we would see everything white because of the shine of the stuff. It's, like I said, because it's so massive that it's nothing is bigger than this. The biggest black hole are always at center of galaxies. Because they are strong enough to...
Galaxies, you're talking about?
Yeah, galaxies. Yeah, not solar system. The solar system, of course, have a star at the center. Okay. A galaxy, most of the galaxies have a black hole.
Yeah, right.
Sometimes we have what we call a galaxy barré. It's a black hole at the center, but who let two rays of light ejecting. In fact, it's a light which is outside of the event horizon. The event horizon is the limit. Like I said, each planet have a freedom, what we call a liberation speed, a speed to extract.
Yeah.
The planet, the Earth, is around 11,000 kilometers per hour. A black hole, of course, the speed exists, but the speed is above 300,000 kilometers, not per hour, per second. It's above this, above the speed of light. But more you go far, more the speed will be reduced. If I am 1 million kilometers away from the Earth, then I don't need this 11,000 kilometers per hour to escape from the Earth. Of course, I will have the prime of the Sun and Jupiter. And,
I understand. But I understand your point, the gravity becomes weaker.
But weaker because we go far. That's why I always have this question. If we go to the center, we know what happened when we know far from the Earth, but we still don't know. That's why I say I would dream one day to do this experience. You make a hole in the ground, and when you make a hole, does the gravity become higher or become lower? Yeah. Because if one day we can do this experience, in my head, I will have my theory about gravity. And I will have in my head a physics quantique of the gravity, which doesn't exist yet. It's not I'm sure of myself saying, yeah, before I will die, but it's a hunt. When you target something, you don't... It's not bad to target more far than we can go. It's not too much proud of yourself, too much pride or something bad.
No, it's going.
It's good to target something what you cannot stuff. And one of my
cannot achieve.
Yes, exactly. One of the targets in my life is to discover this, what we call gravité quantique.
Interesting.
But some people, when I say that, they say, oh, but you are fucking megalomaniac, Jeremy. You even don't have a diploma of hard science.
No, I don't think so.
And I will say, yeah, and Albert Einstein was working in a fucking office of inventions before elaborating his theories. And even if he died old, he wrote his 2 main books at 23. And he spent all of the rest of his life just to explain what he realized. Every scientist, they have an idea. And they try to check if it's wrong, and it's not wrong, so my theory maybe is valid. And sometimes you just have an idea who can become something, a future rule of the universe, you understand? And I really have this dream to one day help, even if I never public or if I just myself, I really would be happy to one day have in my head a theory how to make a good gravity theory of quantum physics. And
I like that.
If I have this answer, trust me, from this answer, by logic, I can have my full theory. Just if somebody explained to me, if I go at 3,000 kilometers in the ground, I will have more or less gravity. In one word, I can tell you, if I have more gravity, it means the gravity is not depending on the atom. If I have less gravity, it means it's depending on the atom, then the graviton exists.
Okay, so what's the graviton? Explain that.
The graviton, we still don't know if it exists. It's an object which we suppose it exists.
What shall I imagine?
It's a microparticle like the boson of Higgs or like the...
That was the next question. Is it like a particle, like atom or electron or not?
It's not like atom or electron.
I understand,
atom and electron, it's a...
I understand, but it's a particle. So graviton, I'm supposed to imagine it as a particle.
Yes, exactly. But particles smaller than the atom because it's... For now, scientists, they suppose it's inside the atom. But if it's inside the atom, it will have a special effect when you go in the center of the Earth, because, okay, you are more closer to the center. We are attracted by the center. So if you are closer to the center, you should have more gravity. But in the same time, you have less material around you and under you. If I make a tube here like this diameter here, this distance between me and the center, you have to make this in 3D, is smaller than the full Earth. So if the graviton exists, then I will be attracted less. If, like I suppose for now, the graviton doesn't exist, I will have the same gravity, because this gravity attracts me to the center.
Okay, my next question is, if the graviton doesn't exist and the closer you get, the weaker it gets, then that means the gravity is on the surface? Or what?
No, that means you have to take in almost first degree this Einstein visuals, which is like something what you make in tension and the stuff heavy make a cone.
Yes, yeah.
It make a cone. You are attracted by the center of this cone.
Yeah.
Whatever the object who are in the middle of your trajectory.
Yeah.
You will be attracted by the middle of the cone anyway. I mean the slide. Imagine originally it's horizontal, and when you make a pressure, it becomes like a cone here.
Yes,
the angle of this will be the same. Even if tomorrow I make you pass through this planet, how can I say? This angle is the same all around. And how can I explain? If you remove a part of the planet to let you go until the center of this cone, without losing weight. Imagine I remove a slice of pizza to let you go. View from the top, this is a cone. And you have a big planet here who makes this. This is like a conic.
Okay, understand.
You are here. You are attracted by the center. Like in my... Like here, you are attracted by the center. Except, of course, you cannot go until the center because you have this planet here. I make it bigger to make it more visuals. Yeah. You cannot go at the exact center because there is a planet who lock you. So imagine I cut like a slice of pizza.
Okay.
But not to change the position of this cone. This slice of pizza, I don't put it away. I just put on the side here. Okay. Like this, the global angle of all of this will be the same, except you have a little opened triangle to let me access to the center. In my metaphor, is the same as this hole here. Okay. I'm sure this angle will be the same here. It will be always the same until you arrive at the center. You understand? If it's like this, so if the gravity is the same until the center, it means the graviton doesn't exist. Like I said, I don't say I have the answer. I say if one day somebody can reply me to that question, in my head I will have a theory of gravity. I don't say it will be the right one, but I will say I will have good argument to defend it. And after I will have to do the other job, which is try to see if it doesn't work. Like I said, first you elaborate a theory and then you try to see if it works in every case. If you find one case when it don't work, when it doesn't work, then your theory is wrong.
Yeah, I understand.
And this idea of making a hole, until now I never found any answer. I never found any answer. Yeah, because like I said, we still don't have this gravité quantique. We know the effect the Earth have about something else, but we don't know what on Earth creates this effect of gravity. On Earth or on anything. Even a black hole. We know a black hole attracts the stuff very strongly, but we don't know technically how. We know it depends on how massive is it. We know how to calculate it. It depends on the mass, on how massive is it, but it's not sure. It depends on the atom who compose how massive is it.
That was my other question, and if you can answer it in 1 minute. How do you know which way is the center of the galaxy if you don't know where is the edge? Or
because of the density of the stars first.
Right, okay.
And because there is a point who do like this, like I said earlier.
Why, like Yeah, okay, so then
only a black hole can create such an acceleration of the stars when you check them.
Yeah, I understand, but like what makes it sure that the center of the universe is a black hole?
Because, like I said, no one. You calculate an object. You know the speed of these stars who turn around.
I understand.
Okay. No. I will continue. You understand? Okay. You know the speed. Okay.
Mm-hmm.
The speed acceleration here, when they go closer, depends on one stuff: the gravity of what is in the center.
Right.
Okay. Like the International Space Station turn on the Earth.
Yeah.
The speed depends on how heavy is the Earth.
Yes.
I mean the gravity of the Earth.
Yeah.
But the gravity of the Earth, like the gravity of this, depends on one stuff.
Yeah.
How massive is it? You understand? So from the speed of this, you can calculate how massive is this object.
Right.
And there is a moment when you arrive at a calculation, which is which speed I need to go away this massive object. And if you do the calculation, you realize this massive object, you will need twice the speed light to go away. So of course it's a black hole, and it's not a small one, it's a massive black hole. Then there is another way, what I know since I'm a child. This is a theory what I had when I was a child. How to get back the center of a circle when you just have the circle. Gravity works in 3 dimensions the same way.
Yeah.
When you have an object, it doesn't attract more on one side than another. Okay? That's why everything is round. That's why the Earth is round. That's why an orbit is round or elliptic when there is an acceleration, but it's just because there is an acceleration.
Yeah.
If you block the ellipse with your gigantic head, if you block a planet, and then if you raise sand with another regularity, it will go round. When you have a round, you don't need to know the center, you can guess the center.
Yeah.
And this is a theory. When I was a child at school, I was thinking, we use a compass. You remember when you were a child, you use a compass to make a circle.
Yeah, like those.
It's very fast to explain, you will understand, and it's totally the subject. Even without these studies of the center or acceleration stars, we could know the center of the center of the galaxy. But just using this. You have a circle. It means we detect our solar system make an orbit. We just need to know the center of this orbit, because we orbit necessarily around something. Nothing is immobile. Nothing is
still.
Yes, maybe yes, but it's a relative question. That's why this theory from Einstein is called relativity.
Yeah.
That's the main point of the relativity. There is no difference between a movement and no movement. It's the same. The only stuff that depends is the acceleration or the slowing down, the change of a force. You understand? No force or always the same force, it have no difference. In mathematics, in scientiation, in physics, in any point of view, no difference between the movement and the absence of movements. So we know we have a movement in circle. Okay? Then we want to know the center. It's easy. We just need to make tangent, a line who touch a border without going in and without going out. At the point of touch, we make a 90-degree angle here, 90 degree, and we necessarily arrive at the center. So you just need to make 2 of them.
Yeah, I gotcha. Yes,
and you get your center.
In mathematics.
And this is when I was child, the way I found to get the center of the Earth. Really, I was in primary school and I was thinking how I can know the center of a point, because at school we learn to use a compass to make a circle, but we never try to do the opposite.
Wow.
After you can ask me other questions about alien form of life, the chance they have to exist, the Drake equations or the Fermi paradox, which I totally disagree. But
anyway, it's basically we discussed 2 hours, so I just wanted to say thank you, and we're gonna finish it next time, or we're gonna carry on next time. But for now, thank you very much.
Yeah, like I said, we can do shorter on one basic subject. If I organize my ideas to focus on one subject before the other. Sometimes I will need to use a paper with examples, but I can focus more on one subject.
Cool. Next time we should do a video about it so people can see.
It's easier to discuss about politics or movies than science for this reason. I mean, not easier to discuss, easier to focus on one point.
Yeah, I understand.
Because there is less interconnection. Like I told you, the universe. Did you know this fact? It's stupid. No, what I said earlier about even in the other side of the universe, it's still the same atoms.
Yeah.
Did you know that? Because some people, they don't realize
no,
it.
not necessarily.
Okay. It's it helps us to understand that all of the universe is necessarily interconnected. It's studying what is just around us or what is so far is the same. I mean the same. Maybe by luck there is a planet just made of gold so far, but even gold we have on our planet, just in another quantity.
Anyway, I'll say goodbye. I turn this off, and thank you very much for the attention.
Okay. You have to stop the recording.
Yeah. I'll do that now.
Thanks to you.
Ciao.
Ciao.